Hi everyone. So let us start AIMT1 solution for gate DA. So there has been a lot of demand. So here it is. So let's start the solution. Let's see this question. So in this question they are asking that there are two statements has been given, and then they're asking which of this is false, which of this is true. Okay. So statement one is saying that Fn is order of n square and Gn is order of n square. So both are order of n square. Then does this mean that Fn is order of or big O of Gn? Which means big O means that less than equal to. Okay. If I just ignore the constant, then it basically means Fn is less than equal to Gn. Okay. So they are saying that Fn is less than equal to n square and Gn is also less than equal to n square. So statement one is saying Fn is less than equal to n square and Gn is also less than equal to n square. Okay. So both are less than equal to n square. Does this mean that that Fn is less than equal to Gn? I think no, right? Why? Because you can take maybe you can take Fn to be just n square, and I mean Gn you can just take n, something like this, right? Then in that case, that n square Fn is basically n square and Gn is just n. So n square less than equal to n, or maybe big O. That big O relation is not possible between these two, right? So even though this LHS is being satisfied, right? Even though this LHS is being satisfied, doesn't mean that this RHS is also satisfied, right? So here is a counter example, which means you can definitely take. I mean, basically, it is not making sense, right? I mean, it is as good as saying that suppose some number, let's suppose a, okay, a is less than or equal to, let's suppose, 100, and b is also less than or equal to 100. Then can you say anything about a and b? Like a is less than b, b is less than a, something like that, right? So we cannot comment anything about a and b, right? I mean, could be a could be greater than b, a could be lesser than b. So similarly, here the cases of asymptotic notations, but the this is a similar kind of case, right? So you cannot also comment about Fn and Gn relationship just because of this, right? So that's why this statement is false. What about statement two? Statement two is saying that Fn is less than or equal to Gn. Okay, F is less than or equal to G, and G is less than or equal to n square, right? I mean, these are the two relations which are given to us. Now, like I can also write these two relations like this. Okay, I mean basically the given was something like this. See, G is less than or equal to n square. Okay, so now they're asking that Fn is also less than or equal to n square. Yes, this is called transitive relation, and which is true in case of asymptotic notations, which means F is definitely less than or equal to n square, right? So if f is less than g and g is less than n square, then f is definitely less than n square. So that's why this is true. Okay. So statement one is false and statement two is true. Okay. So C should be the correct answer. Statement one is false. Statement two is true. Right. So that's why C is the correct answer. Right. Great. Now let's move to this question. This question is basically related to Dijkstra time complexity. So they are saying, suppose we run Dijkstra on the graph with n vertices and edges are order of n log n. Okay, so they are not given theta, they are not given any other notation. It is order of n log n. So basically, number of vertices they are saying are n, and number of edges, see, at most it could be order of n square, if you remember. I mean, this is when the graph is a complete graph, when every node is connected to every other node. Then the number of edges and number of vertices has the relationship of order of n square. Okay, but here they are saying it is order of n log n. Assume the graph is represented using the adjacency list representation. What is the asymptotic running time complexity in case of Dijkstra or Dijkstra algorithm in this case if we use the binary heap for the priority queue? So do not worry about the binary heap if you do not know. So basically the Dijkstra time complexity is given by this. See, let me just remind you Dijkstra time complexity. What do we do in Dijkstra? We basically for a given graph, right? We given graph, we keep on finalizing the minimum. So basically there is something called priority queue. If you do not remember, then that's okay. You just need to remember that we do have the priority queue for every edge, because like I mean we sorry, for every vertex, right? We put the vertices in the priority queue. So for example, this distance of this source vertex is 0 initially, these all are infinity, and then we put the vertices in the priority queue. Then we say that there is a priority queue with all the vertices, right? And we extract min all the vertices. So if number of vertices are v, then we do v log v. I mean, for one extract min, this is log v time, and then we do it v times, right? So just for the extract min, I mean, v times extract min we do. So v times extract min. That's why this time complexity plus we also relax every edge, right? Relax means update the key. Update the key also take log v time, right? Because the priority key is basically of log v. So we do relax. So we relax every edge one time. Okay, so which means if you're relaxing every edge one time and there are e edges, so e into log b. Okay, e into log b. Why that is the case? Because this log b is to update or relax. Okay, you can say it is for the relax or the update the key. Update. Okay, for update key also takes log b. So generally the time complexity is, okay, Dijkstra time complexity, generally it is v log v. Generally means if we are using the min heap and adjacency list. I mean, adjacency list, why we are saying? Because in adjacency matrix there is a additional time complexity, okay, which is order of n square or something. But in adjacency list there is no additional time complexity, okay. Just for the data structure limitation is not there. I mean, this is the better data structure for the digestra, okay, or for most of the graph algorithms. Okay, so v log v is time for v times extract min, because what we are doing, we are basically, for every vertex we are trying to find out what is the minimum vertex or minimum distance. All right. So basically this is ds is 0 initially and everything else is infinity, and then we find out what is the minimum. So v times extract min we do. Okay, extract min, v times extract min we do, plus every edge is also relax once, right? So basically we do e times relax, right? So relax time, relax means update the key. Okay, so update the distance. So update key or relax takes that much time, right? Relax or update distance or update key, right? So finally in register you have v plus e log v time. Okay, v plus e log v time. Now they're asking that if this e, okay, in this question they're asking if this e is suppose order of n log n. So v is anyway n, so which means n plus if e is also n log n, then in that case it will be n plus n log n and log n, right? Which will be n log n plus n log n square. So asymptotically you can say, you can just ignore this term because this term is lesser than this. So finally it is n log n square only, right? N log n square. So let's just see which is the correct answer. So I think in this case C is also correct. Okay, so n log n square. Okay, I hope you understood. By the way, there is one interesting fact that you might be knowing. Let me just tell you that relationship between V and D. See, in general, if this V is n, then this could be as long as or as large as basically order of n square. Okay, or it could be as large as n square. You can say, right? So in general, like you can see, this is the relationship. Number of edges obviously in a connected graph, okay, I mean greater than or equal to number of vertices. This is the general relationship. But interestingly, there's a fact which is like after taking the log, which means that if you take the log, I mean this is before log, you can say before log, but after taking log, okay, after log, the relationship is basically log v and log e, and log v is just log n, and this is also if it is n square, then log of n square, right? which is which is 2 log n, which is as good as log n. So this is also log n and this is also log n, right? I mean, after taking log both are equal, right? But before taking log, this is the relationship. Okay, so I mean, this is not related to this question, but I'm just sharing this information to let you know that before log, this is the relationship. Maybe it is helpful in some other question. Okay, that before log, this is the relationship, but after log, this is the relationship, right? Okay. Now let's see this question. This question was related to, I think, insertion sort or what? Most Yeah, kind of insertion. So let me just tell you that how it is related to insertion sort. So they are saying, suppose that you have an element such that location of each element is at most log n position away from the location it would occupy in the fully sorted array. So basically they are saying that each element is basically at most log n away from its current position that it could have been occupied, it could be occupying in its fully sorted array, right? So in insertion sort, if you remember that what we do, we basically say that okay, let me just push it to the correct position. So basically, in this kind of case, in this kind of scenario, you can say insertion sort is very helpful. Why? We will be taking every element, and then we will be placing its own correct position. And at most since it is at most log and away, so that is why like basically we will start doing this. So it could be at most log and away, it could be also at most log and away, it could be at most log and away. So basically we will be using the insertion sort, and then we will be basically sorting this array. So uh, like each element will be taking at most and log and shift, right? At most log and shift might be required for each element. And since there are n elements, so it will be n into log n, right? N into log n will be the correct answer. Okay. See, if you use any other algorithm, it could take n log n, right? So better to use insertion sort in this case, because it is at most log n away. Suppose it is not at most log n away, it is n away, right? Or maybe yeah, n minus 2 away or something like this, right? Then insertion sort might not be a good idea. It could be the worst case. Insertion sort worst case, right? Then it will be taking n into n minus 2, which is almost like n square, right? It might not be a good idea. In that case, I could have used like merge sort or something, right? Okay. So the thing here is that since it is well suited for the insertion sort, so we will be applying the insertion sort here, because after applying the insertion sort, I am getting lesser than n log n. So why not to apply insertion sort, right? So that's why n into log n. So B is the correct answer here, right? So we will be applying insertion sort here. It was a good question. I hope you like this question. Now let's see this question. This was easy question only. So they are saying the queue is initially empty, and then with the probability p, you will be dequeuing. With the probability 1 minus p, you will be enqueuing. Dequeue means you are removing one element, enqueue means you are adding one element, right? So what is the expected change in the number of elements in a queue after one operation? So with the probability p, you can choose the dq operation. With the probability 1 minus p, you can choose nq operation. So if you choose dq operation, it will be probability p. You can say like this, like it will be nq or it will be dq, right? This could be one of the operation. So if you choose, the nq operation, the probability will be 1 minus p, and the number of elements you will be adding is basically one. I mean, nq will be just adding one element. And with the DQ, you will be choosing it with probability P, and the number of elements that you will be adding is basically minus one. I mean, you are basically removing one element, or in other words, you can say you are adding minus one elements, right? So basically, this is the expected number of elements after one operation. If you're sure, let's suppose if you're sure that you are going to DQ, then expected number of elements will be minus one. I mean, one lesser. If you're sure that you are going to do NQ, which means that this probability is one, which means P is zero, right? If you're sure that you are going to do NQ, then the expected number of elements will get incremented by one. If you're sure that you're doing DQ, then expected number of elements will definitely get decremented by one. But if you're not sure, which means with the probability P you can DQ, with probability 1 minus P you can NQ. In that case, the answer is this, right? So which means this is 1 minus P into plus minus P, which means minus P, right? So it is 1 minus 2P, right? 1 minus 2P. So 1 minus 2P will be the change in the number of elements, right? Will be the change in the number of elements after one operation. Okay. So 1 minus 2p. So B is the correct answer here. Okay. So this was also easy question. I hope you understood this question. Now let's see this question. The following figure shows a binary search tree obtained by inserting distinct keys one by one into the initial empty tree. Select the alternative that correctly represents an instruction sequence with generates exactly in this given binary search tree. Assume that all insertions are performed using the standard binary search tree insertion rule. So basically, which sequence can produce this? That's what they're asking, right? So 30 must be the first. So that's obvious. After 30, there could be 15 or 16. I mean, there must be 15 or 60. Okay. There, I mean, either 15 or 60. So okay, that's fine. And then let's just go one by one. After 15, can it be 40? No, right? I mean, the 40, if you are inserting 40, then it will produce something like this. So obviously, this is wrong. This is wrong. After 15, can you insert 60? Yes, so that's fine. Then 10, 20, 40, 80. Yes, this could be the answer, but let's just check if this one could be the also answer. 30, 60, 30, 60, it will produce this. Then 20, oh no, 20 will produce this, right? So D is wrong. D is wrong. So C is the correct answer. But here, there could be the even more interesting question. The question will be that how many, with these elements, okay, with these elements, how many uh, ways are possible to insert these elements such that you get this tree. Okay, how many ways are possible to insert such that we get given tree? So just think about it. See, 30 must be first, but between 15 and 60, what do you think? I mean, anything can come, right? But the next must be 15 and 60. Sorry, not 16, 60, right? I mean, after 30, you can have either 15 or 60, right? Like, I mean, anything is possible here. So basically, like, you need to count all the ways, right? So we have done this in already in our lectures, but just think about it for a minute and then we will solve it. Okay, just think about it for a minute that how many ways are possible. Okay, just think for at least 5 minutes before you see the solution. Just think for at least 5 minutes. So basically, the thing here is that 30 must be coming first, right? So let me do one thing. Let me just go to the next page and let me just solve this. That the thing is that 30 must be at the first, right? 30 must be at the first, and then one thing is that between this left tree and right tree, like, there is no relation. I mean, there is no constant that okay, 20 should be coming before 60 or something like that. I mean, definitely 15 should be coming before 10 and 20, but there is no exact relationship between these left and right, right? So I can say that 15, 10, 20 is different from this 60, 40, and 80. So, but one thing is sure that 15 should be coming. See, now there are six positions, right? One, two, three, four, five, six. Okay. That I should be choosing. Let me first choose for this left subtree. Okay. So from this sixth position, let me just choose three positions. Okay. Three positions for 15, 10, 20. Right. So suppose any three positions are finalized. Okay. Any three positions could be finalized. Right. So one, two, three, four, five, six. Yeah. So there will be six positions. Out of this, I'm just finalizing three positions. So like there are six C3 ways to choose those three positions. And then one thing is for sure that once I choose those locations, right, then 15 should be coming at the first, right? 15 should be coming at the first. Like whatever I choose, okay, this is one of the example, but whatever I choose. Maybe I'm choosing this, okay? Maybe I'm choosing these three. Okay. Doesn't matter. Maybe I'm choosing, let's suppose, these three. So whatever I choose, 15 should be coming at the first. And then at remaining positions, 10 and 20 can come, which means there could be the two factor. I mean, there is no relationship between 10 and 20. I mean, they could definitely shuffle each other. So there are two factorial more ways, right? Once I choose, first I'm choosing three positions, then I will place in 15. There is exactly one way to place 15, right? Because once these three positions are chosen, then 15 is at the first, right? So there is exactly one way to choose to put this 15. But once I put this 15, there are exactly two factorial ways to put this 10 and 20. Okay. So 6C3 into 2 factorial will be the ways in which I will be placing 15, 10, and 20. Okay, then how many number of the ways to place this? Obviously, for the remaining three positions, I do not have any choice, but 60 should be there. There is exactly one way to place 60, so 60 should be at the first. I mean, wherever I am choosing these three positions, so remaining three will be for 60, 40, and 60. For example, if I am choosing this, okay, you can choose anything, but let's suppose if I'm choosing these three, 4, 15, and 10 and 20 can come like this or like this, right? Okay, so suppose this is just one of the possibility I'm choosing. Let's suppose these three. Okay, suppose I'm choosing these three. Now it's the remaining these three, 60 should be coming at the first, that's for sure. And then there are two factorial ways. So for these three numbers there are, you can say, two factorial ways to put these three numbers, right, for the remaining three positions. So if you solve this, this will be 80. Okay, if you solve this, this will be 80. This is a very nice question. Actually, we have already solved this kind of question in our class. Um, so in our data structures class. So for example, see here, a BST is generated by successful insertion of the nodes from each permutation of the keys. From this, how many permutation determine the tree of height 2? Tree of height 2 means, like, I mean, this kind of tree basically. Okay, height 1, height 2. So the answer was like 80 only, and that's the way we have solved it. And this is actually, I've taken this question from Stack Overflow, like someone has asked from on the Stack Overflow, and the question has been answered by one of the user, and you won't believe who is this. He is Stanford professor for compiler design. In one of his answer, he told that he is a Stanford professor for compiler design course. Okay, so this template type def, he is a Stanford professor for compiler design course, and also you can see his reputation, which is extremely high, 376K, right? It is extremely high reputation on the Stack Overflow. Okay, so 80 is the possible ways to do it, and in the similar way he has also done. Great. So this kind of variation is also possible for the simple question, right? There are 80 possible ways to produce this. Okay, interesting, isn't it? Great. Now suppose let's suppose I ask the same question, I don't have this. Okay, then can you solve this question? So there are many other variations possible. I think you should be able to solve this question. Just comment down your method and your answer. What is the answer? If let's suppose you want you have the same question, but in the same question you don't have this. Okay, you don't have 80. Then what is your answer? You can just comment it out. Okay. Now let's solve this question. This question was easy enough. They are saying a linear classifier is given like this, where t equal to 1, t is the class, basically the final prediction, corresponds to fx greater than 0. For t equal to 0 corresponds to fx less than 0. The classifier correctly classifies all the training samples, and no sample lies on the decision boundary, which means there is no equal to 0 kind of thing. Okay, which of the inequality must necessarily be satisfied by the weights and bias? Select all that apply. So you can just substitute the value. So here, uh, if you put all zeros, then b you will be getting, and it should be since it is corresponding to t equal to 1. So b is greater than 0, right? B is greater than 0, you will be getting. Why? Because you substitute x1, x2, x3, which are all 0 for this example, and then you will be just getting b, and it should be greater than 0 because t is 1. So b is greater than 0. If you substitute this, then you will be getting, I think, only W2 plus B. W2 plus B should be less than 0. Yes, it is less than 0. If you put this, since T is equal to 0, so it should be less than 0. If you put this, then you will be getting W2, W3, and B. W2 plus W3 plus B should be greater than 0. Yes. If you put all of this, then it will be W1 plus W2 plus W3 plus B is greater than 0. But here is something very weird, which is W3 plus B is less than 0. I mean, it is possible only when I'm having 0, 0, 1, 0. This kind of example, right? If I'm having this kind of example, then this could have been possible. But currently, I don't have this kind of example where 0, 0, 1, 0 is not there. So that's why all of these three are possible, but this D is not possible. Okay. Not implied by any training example. This was easy question. You just have to substitute and see what are the correct answers. Okay. Now let's solve this question. Here they are saying, consider a k-fold cross validation on a linear regression model with a sufficiently large amount of training data. When k is large, the computational complexity of k cross validation with respect to k is the order of. So basically, they are saying that for the k-fold cross validation on a linear regression, right? They're asking that computational complexity of k-fold cross validation with respect to k, how it is going. I mean, don't worry about the other things. With respect to k only, they're asking, right? Other things you can take constant. Okay, other things means data size and all you can take in those constants. So what is the k-fold cross validation? We have the training examples. We basically divide those training examples into different folds, right? Into different folds like this, right? Okay. So basically, I have the explanation here. So what we do, we have in k-fold cross validation, we basically divide the data into k folds, right? And then the model is trained basically k times, each time leaving out one fold for the validation and remaining k minus one fold for the training, which means that these are the, let's suppose, k minus one folds. Okay, so we are keeping k minus, we are training on this, we are testing on this fold. Okay, that's called k fold cross validation. Okay, so how many times we are basically training? We will be training k times, right? I mean, one time we will be leaving this, one time we will be leaving this, one time we will be leaving this, like that, right? So we will be training k times. So k times we will be training into cost of training, right? Cost of training once. So let's suppose this is constant. I mean, they are asking just for with respect to k. So k into cost of training once, right? So which means it will be growing linearly with k. If k is large, then we will be having the more, we will be spending the more time. If k is less, then we will be spending the less time. Okay, so order of k will be the answer. Great. Now let's solve this question. Which of the following transformations to the data matrix x will affect the principal component through pca? So they are saying that in PCA, which of the following will affect the PCA basically, right? So what is PCA? We basically have some steps in PCA. What we do, we have data, and we just like you can say centralize the data. Okay, so this is centered data. Centered data means that for every feature we are making the mean to be zero, which means if data is this, these are the three columns or these are the three features in the data, we find out the mean and then we subtract from every data point, we subtract that mean. Okay, so that ultimately the mean is zero, so that's why we call it centered data. Okay, and then we find out, let's suppose this is the centered data, then we find out something called as covariance matrix. Covariance matrix of data, right? So covariance matrix is basically, I mean, in general, it will be basically x minus, you can say, mu into x minus mu transpose, x minus mu whole transpose, and divided by total number, for example, something like this, right? But since it is you can say centered data, so that's why mu is already zero. So you can just take it x into x transpose, right? I mean, if let's suppose this is x, where these are the, let's suppose there could be any number of examples, but let's suppose there are three features. Okay, then in the covariance matrix it will look like this. The covariance matrix will look like this. This is basically between the features, the covariance is between the features. So it will be 3 cross 3 irrespective of this, right? Irrespective of this. So you can say in this case, I mean, if you're writing your examples in the row and features in the column, in this case the covariance matrix will be x transpose x, right? So x transpose x will be the covariance matrix, because ultimately dimension we want 3 cross 3. Okay, so x transpose x could be the covariance matrix. So either x transpose or x transpose x, depends that what is the notation that you're following for the data. Okay, so maybe for this example I can just keep it as x transpose x, doesn't matter. Okay, I'm just telling you how does the pca look like. So you find out the covariance matrix, which is like x transpose x, then you find out the eigen. Basically generally it is divided by n. Okay, I mean, you have to divide by n because this is the formula of covariance, but ultimately we are again going to renormalize the eigenvector, so that's why I'm not dividing by n currently, because you can later divide or you can later normalize the eigenvectors. Okay, because ultimately the eigenvectors should be the length of the eigenvectors in the PCA. We want it to be 1. Okay, sorry, length of the eigenvector, which is, let's suppose x is the eigenvector, then we want that to be 1. Okay, Anyway, so basically, you find out the eigenvectors of covariance matrix, and then you just take the highest eigenvalue, then second highest eigenvalue, and so on. Okay, this is how PCA works. Now let's just check the options. They are saying that adding a constant value to all the elements x. So if you add the constant, okay, if you do not worry about the mathematics, just see the intuition of the PCA. If you add the constant, then PCA work on the very simple thing, which is the maximizing the variance. I mean, it basically find out the direction which is maximizing the variance. For example, if this is how your data look like, okay, let's suppose this is how your data look like, right? So in this direction, in which direction the variance is maximized? So you will say in this direction. This is the direction for maximum variance, right? This is the direction for maximum variance. Now what I'm saying is that uh, that PC is basically finding the direction of the maximum variance, right? So anything which is disturbing the variance will be disturbing PCA. Okay, so you can say anything which disturbs variance will disturb PCA result also, right? Which means if I add some constant, so you might remember that x plus, let's suppose, some constant c, the variance of x plus c is same as variance of x. I mean, uh, adding the constant doesn't disturb the variance basically, right? So if you add the constant, it won't disturb the variance, so it will not impact the PCA, right? So they're asking, will affect the PCA? It will not. Okay, it will not impact the PCA. Okay, no impact. Adding an extra feature that is a constant across all the data points. So basically they are saying just add some constant feature, which means you are just adding one extra dimension, which is not helpful because the variance of constant is actually zero, right? I mean, PC will not pay attention to that feature, so it will also not impact. No impact. Okay. Multiplying one of the feature x by constant. So if you, yeah, this is interesting. If you multiply, then it will, let's suppose you are multiplying, right? Then it will basically, so currently let's suppose this is the dimension in which the spread is maximum. But multiplying some constant, let's suppose I'm multiplying this y, right? Then it might give the data points like this. Okay. I mean, it might spread this, right? Because multiplying something, mathematically also, you might remember that variance of a into x is equal to variance of x multiplied by a square. So basically if you multiply something, some constant, right? So this is the data that you have. But let's suppose in one of the feature, you can take any feature. Let's suppose currently I'm taking this y feature, right? So if you multiply, then this value, whatever the y, it will be lifted. So after multiplication, everything will be lifted, right? And if it is, let's suppose, I mean, the spread will be basically more, right? Spread will be more, right? So if earlier between two values, okay, y values was 2 and 3, or y values, let's suppose 2 and 10, okay, I mean one of the y value is 2, another y value is 10, right? So after multiplying, let's suppose 2, then one of the y value will be 4, another y value will be 20. So the difference here is 16. Earlier the difference was 8 only, right? So since the spread is basically getting increased or maybe decreased, like if you are multiplying fraction or something, it may get decreased also, but it is impacting the spread of one of the dimension. That's the point, right? So if you are multiplying by some constant, then the spread might get changed, and hence the variance will get changed. And mathematically also, you can see the variance will be changing. So this option is dangerous. I mean, if you multiply by some constant, then this option is definitely dangerous. Okay, so this will impact PCA. So hence C is the correct answer. I mean, they are asking whichever will impact the PC, you should answer that. So C is the correct answer here. Okay. So answer is C. Or and also mathematically you can see that, okay, if you find out the variance, then it will be C squared, something like that, right? And this is the covariance formula, covariance matrix. If given that mean is zero. Okay. Now let's solve this question. this was easy question because I mean this was linear algebra question, and because it was related to Kelly-Hamilton theorem. I mean, if you notice that that this was Kelly-Hamilton related question, so you can solve this question by writing the characteristic equation. Okay, so what you have to do, you can write the characteristic equation, and then you can solve this question. So basically, let me just go to the next page. So basically, if you do minus lambda minus lambda minus lambda, and then you find the determinant, then you will finding the characteristic equation, which is lambda minus 1 into lambda plus 2 into lambda plus 3. So this will the characteristic equation. Now, according to the Kelly-Hamilton theorem, okay, every matrix satisfies its own characteristic equation. This is very important theorem. So you can write like this, and then the moment you write like this, you can multiply by the A inverse. This is a very standard technique, and you might have done like this. I mean, you might have solved these kind of questions before also. And if you've not solved this, fine. Like basically, Kelly-Hamilton theorem says that every matrix satisfies its own characteristic theorem. Characteristic equation. Characteristic equation means the equation using which we find out the lambda, or you find out the eigenvalues. Okay, so this is your answer, and then if you compare your ABC, then you will be getting your ABC. Yeah, this is interesting question, and this is one of the fundamental question that they might be asking. This is kind of, may not be directly, but you can say this could be the indirectly potential gate question. Okay, so let me just name it potential gate question, because this is very important theorem. So here they are saying that A and A transpose, they are basically comparing between A and A transpose. Like A is given that A is of size m cross n. Then can you tell me size of A transpose? A transpose will be of size m cross m, right? Then which of the following is or are necessarily true? That's what they're asking. Okay. So basically, let me first tell you the relationship between rank of A and rank of A transpose. Okay, actually both are same, and there is very easy proof. I mean, not very easy, but if you have seen that proof, you might be able to recall. Okay, so how to prove it? Basically, we will be proving with the null space, okay, or the nullity. So we will be saying that if nullity is same for both of the matrices, then by the way, this matrix is m cross n, this matrix is m cross m. Okay, if nullity is same for both the matrices, then obviously the rank must be same. Okay, so we will be proving that if X is in the null space of, let's suppose, 8A, okay, then it is also in the null space of AA transpose and vice versa, which means the null spaces are same. Okay, if null spaces are same, then nullity will be same, and if nullity is same, then rank will also be same. So how to prove it? You can just take this direction. Suppose that X is in null space. So basically, this is null space, right? If X is in null space of AA transpose, then what does this mean? It basically means that A transpose X is equal to 0, right? Then you can multiply X both side, and then you can have X A transpose X equal to 0, right? Sorry, you can multiply X transpose both side, okay? And then you will be having this. Then you can notice that this could be written as, this thing could be written as AX transpose, sorry, A transpose X transpose into A transpose X, which means if you just open up this, you will be getting this X transpose A, right? And this is nothing but a vector. A transpose X is actually a vector, okay, multiplying a transpose of a vector multiplying its own vector, so it is X square, which is like a scalar number, right? It is just a scalar number, which is A transpose X is a vector, and length of that square, right, which is 0, which means if the length of any vector is 0, then the vector itself has to be 0, right? Which means you can say, so yeah, basically we are going to prove first rank of A transpose, okay? Rank of A transpose and rank of A transpose are same. So from here you can say that A transpose X must be 0, right? So if if some vector is in the null space of A transpose, then it is in the null space of A transpose also. Okay. So I hope that is clear to everyone. I mean, that's very easy. I mean, not very easy. Again, if you have seen this proof, this is a standard proof that we have done in the class also. So you just multiply with x transpose, and then you get to know that okay, if x is in the null space of this, then x is in the null space of this also. And this direction is also very easy. Like I mean, this direction which is x is in the null space of, let's suppose, a transpose, then automatically x is in the null space of a transpose. Obviously, right? That's very easy. I mean, if A transpose X is 0, then A transpose X is 0. You can multiply A both side. Okay. Which means, I hope I'm not over complicating it. This is just I'm giving you proof. Okay. If X is in the null space of A transpose, then X is in the null space of A transpose also. That's very easy, because if A transpose X is 0, then it's very easy to say that A transpose X is also 0. Okay. So basically, I can say that both the directions are possible to prove. So that's why rank of A transpose and rank of A transpose are same, which means rank of A transpose and rank of A are obviously the same, because it is just number of independent rows and number of independent columns are same. So rank means like number of independent rows e- equal to number of independent columns equal to rank, right? So taking the transpose doesn't impact. So basically, rank of A transpose and rank of A is same. This is very important, you can say, result of linear algebra. And from this they are just asking the question, right? So rank of A transpose, since it is invertible, so this rank is m. Okay, this rank is m because it is equal to its dimension. A transpose rank is m. So similarly, hence the rank of A is also m, right? Hence the rank of A is also m. So this is wrong. M equal to n, there is no guarantee. And A is invertible also. There is no guarantee. It has to be first a square matrix, right? I mean, there is no guarantee about it. So rank of A is equal to M. This is the correct answer. Okay. Yeah. So I think I have not written the answer, but that's fine. So A is the correct answer. So this is a small proof that we have just done. Okay. Now let's solve this question. This question was also nice question. I think one of the student also commented that this was really nice question. So especially especially this option A. Okay, option A could have been little tricky for you, because generally just mark it true instead of just thinking it very precisely. So what is this is saying, that consider a real matrix A, which is m cross n, which of the following statement is or are necessarily true. If row space of A is R power n, okay, see, A is mn to n, right? Which means m rows and n columns. So n columns means there are like every row is from Rn. And how many rows are there? M rows are there, right? M rows are there. Now they are saying if row space of A is Rn, which means they're like basically completing the Rn. Okay, then column space of A is Rm. So by the way, column space has to be, see, dimension is same, right? I mean, if this option is like, if row space dimension is n, then column space dimension is n. See, if this option is say the dimension of row space is n, then dimension of column space is also n, because that's the theorem. I mean, they have to be same, right? Column space is also n. That's correct. But they are not saying this. I mean, this is different from what they are saying. They are saying that that column space is of age Rn. See, column space, every column is in Rm, right? Every column is in Rm. So column space have to be either Rm or subspace of Rm, right? See, just tell me one thing. Is R3, or let's suppose R2, a subspace of R3? It seems like true, but it is completely false. Okay, R2 is not a subspace of R3. These are the two different spaces. Yes, you can say that that there could be two-dimensional subspace possible in R3. Okay, but in R3, whatever is the two-dimensional subspace, let's suppose these are the two-dimensional subspace. I mean, this is forming a two-dimensional subspace. Then the vectors from the R3 only, right? They cannot be from the R2. I mean, this having anything which is like two dots, right, or two numbers, cannot be from R3, or cannot be the subspace of R3. Okay, so two-dimensional subspace is possible from R3, but that won't be R2. Okay, see, let's suppose this. I tell you this. Okay, one. 0 0 1 0, sorry, 0 1 0 0 0 1. Okay, this is, let's suppose, forming R3. Okay, this is suppose forming R3. Now suppose if I take only these two vectors, which are 1 0 0 and 1 0 1. Okay, is this subspace of R3? Yes. Is this R2? No. This is not R2. This is not R2. This is a subspace of R3. Yes, that's true. This is a subspace of R3, but this is not R2. Actually, R2 can never be. R2 can never be the subspace of R3. Okay. So the column space will be the subspace of Rm, which could be matlab n dimensional, but it won't be Rn. Okay. So that's why H falls. Okay. I think one of the student also commented similarly. And see, there's a reason why this question or this answer got six upvotes. Like people are not upvoting, so even six upvotes in Gate DA seems to be bigger number for me, because I don't know what is preventing them to appreciate the question. I don't know what is preventing them to appreciate the answer. They are very reluctant to upvote. They are very reluctant to comment. Okay, very fair upvote. Very few upvote we see. So six upvotes comparing like other upvotes is decent enough for me. Okay, so A is wrong. Yeah. What about B? If null space of A is Rn, okay. See, they're saying null space of A is Rn. Then the column space of A is zero vector. So you might be remembering that null space and row space are perpendicular to each other, right? So if it is Rn, then row space will be what? See, row space is a basically is at most Rn, right? So you can say that from this Rn, there will be some null space and some row space. I mean, both will be orthogonal to each other. So row space and null space. You can divide this Rn into two parts. Okay. And they are saying the column space, sorry, null space is Rn. Null space is Rn, which means they are saying this is Rn. Then obviously row space must be zero, right? Row space must be zero. If the null space is Rn. And if row space is zero, then column space must be having the dimension zero, which means the dimension zero means zero. So the column space must also be zero. Okay. So this option is true. B is true. See here, B is true. Right. So by the way, let me just read the explanation for A. So in the explanation also I have written the same thing. The dimensions are same, but this does not imply that that basically R2 is a subspace of R3 or something like this, right? Okay. So I have given the example, the same example I have given, which is fine. Let's see option B. If null space of A is Rn, then Ax equal to 0 for every x, which means that yeah, no, basically this is actually a better representation that Rn will be having two parts. So any vector in Rn actually, okay, any vector in Rn, this is called orthogonal complement representation of any vector. If any vector r x is in Rn, then you can basically write that vector x as summation of two vectors. Okay, one is in W, another one is in orthogonal complement of W. Okay, W here is you can take null space or row space. Then orthogonal complement of row space is basically null space. Okay, if x is in Rn, then you can do something like this. Okay. So if it is a better representation if you can say if they are saying that this whole is Rn, then this has to be zero. Okay, let's just read out this definition, this answer also. This implies A equal to zero, which means yeah the same thing they are saying, right? This implies A equal to zero, which means that the row space must be zero. Okay, let's see option C. If left null space of A is Rm, then column space of A is zero vector. The same thing they are saying, right? So left null space means null space of A transpose, right? So here they are talking about null space of A transpose. So let me go to the next page. Just a second. What has happened? Yeah. So basically, they are saying in option C that uh, left null space they are talking about, right? If left null space of age Rm, which means null space of, basically they are saying null space of A transpose is Rm. Okay. Basically, Rm could be divided into two parts. You can say something like this: null space of A transpose and row space of A transpose, right? Now they are saying that if this whole is Rm, then this row space of A transpose must be zero, or in other words, column space of of A must be zero, right? That's what they are saying, which is true, right? Column space must be zero space. So this is also true. Now option D is saying if row space of A is Rn, then column space of A is Rm. No, this is wrong, right? I mean, if row space of A is Rn, which means that's fine. That okay, they are basically spanning Rn. Then column space obviously cannot be Rm. First of all, right? I mean, until and unless m is equal to n, right? I mean, if the it means the dimension of row space is n, then column space dimension also must be n. Okay, so it cannot be first of all Rm. So you can say the better wording could be here that column space of A is subspace subspace of Rm, which is n dimensional. Okay, which is n dimensional. Okay, I'm not writing the whole thing, but I hope you understood, right? So basically, the better wording that column space of A is n dimensional subspace of Rm, n dimensional subspace of Rm. Okay, this is correct. If they write something like this is correct because they both must be having the same dimensions. Okay, great. Now let's just move to the next question. So B and C are the correct answers here, right? This was easy question, but yeah, option A was little tricky, I think. Okay. Okay. Now let's solve this question. So in this question, they are saying that null space is basically they are saying the consider matrix whose null space is NA, which is spanned by a vector V. So what does this mean? Basically, if you want to project any vector X onto, let's suppose, any vector V, then what is the projection matrix for this? So you might remember the projection, right? The projection looks like this. If you want to project X onto V, then it will look like V transpose X upon V transpose V into V. This is basically in the vector form, or and you can say this is projection of X onto V, right? Projection of X onto V. So this is basically in the vector form, and you can also rewrite this as something like, okay, V transpose V. Okay, I think yeah, V transpose V. So I think I have already written this. So yeah, it will be VV transpose. So if you rewrite this, this is the projection of X onto the V, and if you rewrite this, this will be in the matrix form actually. Okay, which is like VV transpose is matrix. So you can rewrite this in a way that here you can consider this V transpose X upon V transpose V, sorry, V transpose V into V, right? This is the thing. And now I want to somehow take this X here, right? Take this X here. So how you can do it? You can probably do something like this. See here that this is just like a matrix multiplication, or the or not exactly matrix multiplication, but yeah, you can treat it like a matrix multiplication of three vectors. I mean, vector is also a matrix, right? So it will be V transpose. You can basically multiply X and V first, right? I think actually I want to take this X, right? So outside. So what we can do? Okay. So I think we can write this V. Okay. I mean, since this is a scalar, right? This is scalar. This is scalar. So instead of writing like this, we can write this like this. Okay. So we can write this V. Okay. From here we can write it here. I mean, you multiply C into B or V into C, doesn't matter. If it is C is scalar, right? So you can write this V here. I think it will be easy then. then V into V transpose X upon V transpose V, right? I mean, this thing is as it is. Okay, this thing is as it is. It is just that I'm writing the V instead of on the left side, I'm writing on the, I mean, instead of right side, I'm writing on the left side. Okay. So basically this thing is same. So let me use the same colors so that it is better. Yeah, this thing is same. Okay. Now it is very easy because all of these three are vectors. So you can multiply first two vectors V into V transpose upon V transpose V into X, right? Now you can write like this. Actually, my whole idea is to write the X at the last. Okay, and for that I can bring this V first. Okay, that's fine. So basically you can write like this. Now this is basically the projection of X onto V. In other words, you can say this is actually a matrix. This is outer product, as you already know. So you can, in other words, you can say the projection matrix. Okay, the projection matrix will look like this. This is a projection matrix. If anyone wants to project on V, okay, or the space is spanned by the V, then you can do like this. Okay, PV. So PV is the projection matrix here. So what the question is saying is that if n is the null space spanned by the non-zero vector V, then which of the following matrix represent orthogonal projection onto the row space of A? So what is the projection onto the null space first of all? So projection matrix for null space. It is basically since null space is spanned by V. Okay, so let me write it. So projection matrix on null space, right? It will be VV transpose upon V transpose V. Okay, this is the projection matrix on the null space. Which means if you want to project on the null space, if X wants to project on the null space, then what will the answer? Let's suppose if I'm representing like null space, something like this, right? Then answer will be like projection of X onto the null space. Projection of X onto null space is equal to null space into X, right? So this will be the answer. Is this okay to everyone? Now they're asking, now they're asking for the same matrix but for the row space. Okay, so these things we have already done in the class, but let me tell here also. So basically, any x can be decomposed into two things. One is that x you can write in the null space plus x you can write in the row space if both are the complement of orthogonal complement of each other, which means both are forming Rn and both are basically perpendicular to each other, right? Then you can write like this. And x null space you already know. Okay, so I think I already have the slide. So basically, x can be decomposed into xw plus xw perpendicular, which means projection of x onto w and projection of x onto w perpendicular. So let's suppose this is px. Okay, I mean p. Let's suppose I already know this is px. Then what about this? See, what can be the summation of these two that can give you x? Can you tell me? What can be this summation? It will be one. I mean I minus p, because p is a matrix, I minus p into x, because if you sum this, then it will be x minus px, and px will get cancelled. Finally you will be getting x, right? So basically you can say that if you know the projection of x onto w, which is p, then projection of x onto w complement is basically I minus p, right? If both are complement of each other. So if we know the projection of um, projection of x onto this null space or onto this V is basically this, right? Then what is the orthogonal complement of the null space? Row space, right? So basically projection of x onto the row space will be, so basically you can say this matrix. Okay, so this is nothing but P of null space of V into x, I mean Px, right? Then this matrix will be I minus null space of V in, okay, into x. So basically the remaining matrix will be I minus p. Okay, which is I minus p means V transpose upon V transpose V. Okay, so V transpose upon V transpose V, I minus V transpose upon V transpose V. This will be the correct answer. This was also easy question. I hope you were able to solve this question, right? This was related to the projection and also related to the thing that row space and null space are orthogonal complement of each other. Okay. So this is the correct answer. Now let's solve this question. In this question, they are saying that there is a population of 50 units. The only possible samples that you can take is basically 1, 1, 2, 1, 2, 3, like this, right? One of the sample is selected at random, and each sample has same probability of being chosen. Okay, so which means I think there are 50 samples, like 1, 2, 3, like that. There are 50 samples, and they're saying for unit I, let pi be the probability that unit I is included in the selected sample. Okay. For example, if I is 8, then p8 is the probability that selected sample contains 8. Okay. Then which of the following statement is correct? So basically, they are saying what is the probability to choose the sample that has I, which means pi. So what will the samples which will be having I? So there are like samples like 1, 2 till I, right? This sample will be having I, 1, 2, I plus 1. This sample will be having I, and similarly 1, 2, 50. This sample will be having I, right? With this sample, I actually have everything. So what is the probability of selecting any of this sample? That's what they're asking, right? So if there are total 50, right? 1, 2, 1, 2, and I minus 1, like that, right? So till now, like, I mean, before that, there will be a sample which will look like this: 1, 2, I minus 1. Okay. So see, till now, before that, there are how many samples you have? I minus 1. Okay. I minus 1 samples you have. These are how many samples? These are, I mean, total, if there are 50, then 50 minus I minus 1, right? So they are saying what is the probability of selecting any of this? I mean, if it is uniform probability, then you can say that these are the favorable cases: 50 minus I plus 1 divided by total number of samples, which are 50, right? So I think this is 51 minus I plus 1. Okay. So this is 51 minus I plus 1. So sorry, 51 minus I divided by 50. So since 51 minus I divided by 50 is not the answer, so that's why D is the correct answer here. Okay. Intentionally, I have put this as option, and I have not put this as option because I just want you to solve it very clearly. Okay. So basically, D is the correct answer here. Understood? That was easy question. So basically, you can say these samples, if you want to count these samples, these are 50 minus. I mean, before that, I minus 1 samples are there. I minus 1 samples are there. So these are 50 minus I minus 1, right? 50 minus I minus 1, which are as good as 50 minus I plus 1, or in other words, 51 minus I. Okay. So these are 50 minus I plus 1, or 50 minus in bracket I minus 1. Understood? Okay. Now let's solve this question. In this question, they are saying, let x be the random variable which is symmetric about 0. Let f be the cumulative distribution of x. Which of the following statement is always true? So see here that fx. So by the way, they are saying that is symmetric about mean, symmetric about 0. So what does this mean? It means like, I mean, this need not to be normal distribution. I'm just saying that, I mean, this is the very easy example I'm taking. So don't think that it has to be like that. I mean, it could be. Um, I'm not very good at drawing, but yeah, it could be something like this, and the same thing could be happening here, right? I mean, this is basically has to be symmetric. Basically, you can just take the mirror image of this, right? Has to be symmetric about the mean, okay? Symmetric about the zero, basically. So what does this mean? Symmetric about zero. It means that probability of, let's suppose this is minus x, this is x, okay? First of all, let's just write some probabilities. Probability of x equal to minus x is same as probability of x equal to x, okay? Similarly, probability of x less than equal to minus x is same as probability of x greater than equal to minus x. Okay. Symmetric about mean means this is a mirror image. Okay. So basically, the symmetric about not mean. Basically, here they are writing 0. So symmetric about 0 means what? Probability of x equal to minus x is same as probability of x equal to plus x. Okay. Similarly, probability of x less than equal to minus x is same as probability of x greater than equal to x. Okay. Something like this. This is symmetric about 0. Now they are saying, what is the summation of fx, which is the CDF cumulative distribution function, and f of minus x. So let's just solve this. So what is fx? Fx is probability of x less than equal to x. What is f of minus x? It is probability of x less than equal to minus x, right? Now you can also write the probability of x less than equal to minus x as probability of x greater than equal to x, because it is from here. I mean, you can take from here. Okay. So if you sum these two, okay, if you sum these two, it will be one is less than equal to x, another one is greater than equal to x. So if you sum these two, let me just sum it up. So which is basically fx plus f of minus x, f of minus x equal to probability of x greater than equal to x. Let me write less than equal to x first, and then probability of x greater than equal to x, right? This is the summation. So you notice here one thing is that equal to x is being counted twice. I mean, probability you can take any x. So basically, probability x less than equal to x, greater than equal to x. But this equal to x is being counted twice, right? Equal to x is being counted twice. So what to do in this case? I mean, you can basically write it. Basically, this is a whole probability which is like 1 plus probability of x equal to x. Why that is the case? Because I'm counting it twice. Okay. So basically, you can, if you are not, very much sure that what I'm saying, you can write like this: probability of x equal to x. I mean, basically, you can break it down into two pieces because I'm counting this equal to x twice. So basically, if you add these two, then it will be 1 plus probability of x equal to x. Okay. So that's what the question is. This is basically 1 plus probability of x equal to x. So C is the correct answer. That was also easy question, but yes, it was good to solve that question, right? That's why it was 1 mark question. Okay. Now let's solve this question. Here in this question, they are saying probability of y1, y2 are the independent random variables with minus 1 and plus 1. They can take minus 1 plus 1 with equal probability of 1 by 2. Now x1, x2 and xn, in general xn is defined like this. So which means x3 will be x 2 into x1. x2 is basically y2 into y1, right? x3 will be like this. x4 will be x3 into x2. x3 is actually already y2 y1 and x2 is y2. So since y2 is y2 coming twice, it is like y2 square. And since the value can be minus 1 plus 1, so whatever is the value of y2, okay, it will be actually y2 square will be 1, right? y2 square will be 1. So that's why it is y1 only. So x4 is y1 only. And they're asking probability of x4 equal to 1, which means they're asking probability of y1 equal to 1, which is given as 1 by 2, right? So B is the correct answer. Okay, B is the correct answer. But here, actually, in this question, I mean, they have asked this only, but the question could have been more interesting if they asked something random like x10 or something. Okay, why that is the case? Because if you open x4, this will be y1, but x5 will be y1 into y2, y1, and it will be y2. Okay, so if you notice, this is y1, then y2, y2, y1, then y1, y2, and then x6 will be again y2, y1. Okay, like that. Okay, so basically, if they ask anything else, then this is a pattern, and this could have been more interesting, right? So these probabilities are directly given. What about this probability? What about probability of x9? Okay, x9 equal to 1, something like this. For that, you can say that either both of them are 1 or both of them are minus 1, right? So both of them are 1. The probability is basically 1 by 2 into 1 by 2. Both of them are 1. Or both of them are minus 1, right? Or both of them are minus 1 is basically 1 by 2, 1 by 2. Again, this is 1 by 4 plus 1 by 4. Again, this is also 1 by 2. Okay, the probabilities are 1 by 2, which is fine, but the pattern is more interesting here. Okay. So, by the way, just let us know that how many of you want to modify this question for future aspirants and want to directly ask these things, okay? X8, X9, like these things, okay? Or maybe some X500. How many of you want us to, ask for the probability of X500 being 1 by 2 or something? Okay, sorry, 1 or something. Okay, just let us know in the comment. Like sometimes we do not know as an aspirant like whether it will be too tough for you if you directly ask these things, because I think I mean in gate they can easily ask x500 or something like that, right? Because you should be able to find the pattern. But since it was 1 mark question, we thought that not to overdo it. So that's why we have diluted this question. But it could be possible that we could have asked x500 or something directly. Okay. Just let us know how many of you want to modify this question so that we ask this. Yeah, let's see this question. This is a bit tricky question, I can say, because of this particular assignment. Okay, let's see what they're saying. So x0, they are saying x0 is one list which is basically zero. I mean, one of the element is zero, another one is none. Okay. X1 again they are saying the same thing, 0 and none. This is 0 and this is none. X2 they are saying very interesting. They are saying this is 3. First element is 3 and the second element is x 2 itself. Okay, sorry, I'm writing x2. Okay, x2, in x2 they are saying 2 and the second element is x0 itself. So in Python everything is object, which means this will be basically kind of pointing to x0. Okay, pointing to x0. Now x3 they are saying is 3x2, so basically it will be 3 and then it will be kind of pointing to x2. Okay. Now x31, this assignment is basically bit interesting and this is called chained assignment. Okay, x31 equal to like this and like this. Okay, so this is called chained assignment. So let me first tell you about this assignment, which is called actually chained assignment in Python. Okay, so here they are saying x31 equal to x311 equal to x1. Basically, let me first tell you a bit theory about the chain assignment. If you just Google chain assignment in Python, then you will be finding it. Okay, so basically on the stack overflow, they are asking the same thing: x equal to y equal to some function. So how does it get evaluated? Okay, so in the Python, basically it treats like this. It it actually assign the leftmost thing first. Okay, but in some other way, which means it says that everything is equal to actually this some function only, but first x equal to some function. Okay, so you can treat it like this. Okay, temp equal to some function. Okay, and then everything is equal to the temp. Understood? So probably see below they have given one more example. Yeah. So for example, let's suppose this some function is returning just empty list. Okay. So if I'm doing like this, then it will be x equal to the temp, right? So temp is basically the empty list. So if I'm doing x dot append, then that empty list will get appended by 4, and then some by equal to also the same empty list temp, right? I mean, I'm not calling this function again. This is important. Okay, I'm not calling this function again. The by is also the temp, so automatically by is becoming 4. Okay, I'm not appending 4 to by, automatically by is becoming 4. So I hope this is a little bit clear, but let me just solve the question. It will be more clear. Okay, so the chain assignment in Python are actually little different from what we have studied. I mean, we have not studied the chain assignment, I think, but gate may ask. So that's why sometimes we learn the things from the test series. Okay. I do not remember if we have covered this topic, but if we are not covered, don't worry. Like sometimes we ask these questions so that in case if gate asks, you get to cover this from the test series. Okay. So how does this evaluated? See, we have already made this kind of list, which is okay. But yeah, this will be something like this. X3, X3 of 1. Okay. So let me immediately first make all these list. X0 is basically 0 and none. Okay. X1 is 1 and none. X2 is, let me write X2 here. 2 and pointing to X0. Okay. And X3 is 3 and pointing to X2. Now, x3 of 1 will be equal to x1. x3 of 1 means this. Now, it will start pointing to x1. Okay, it will start pointing to x1. And x3 of 1, 1 is also pointing to x1. See, this is interesting. The x3 of 1 is this, which is pointing to x1. Now, x3 of 1, 1, which means this, right? x3 of 1 is this, and x3 of 1, 0 is this, x3 of 1, 1 is now this, right? x3 of 1, 1. Now, this will also start pointing to x1, which means self, okay? It will start pointing to itself. Now, actually, they are not asking about the x3. They are only asking about the x2. x2 of 1, 0. What is x2 of 1 0, x2 of 1 is this, and 1 0 is this, right? So 0 is the correct answer. Okay. So this, that's why this is little more interesting. Suppose you do not know about, the chain assignment, then you may fall in this question, and then you may do it incorrect. How? Let me first tell you. See, x0, immediately let me write 0 none, it is 1 none, it is 2x0. So x2 is, this is x1, this is 2, and then it is pointing to x0, and then x3 is basically 3, and then it is pointing to x2. Okay. Now suppose you treat it like this. You treat like this, that this is happening first. Okay. Which means x11 is equal to x1, which means x11, x0, x1, right? Sorry, x311. So basically, suppose you are doing this, okay, doing this first, which means you are basically treating like this, x311 equal to x1, and then x31 equal to whatever is this, right? I mean, which is basically same as x311 or x1, doesn't matter. Okay. So basically x311 is this, equal to x1. Okay, x1 is this, right? It is pointing to this. And then x3 of 1, x3 of 1, sorry, x3 of 1 1. Okay, x3 of 1 is this, of 1, which means this, right? X, which means this, x3 of 1 1. Okay, this is x3 of 1 1 equal to x1. Basically, if you do this first, then it will start pointing to this. That will be a problem. And then x1 of 0. Okay, x1 of 0 is basically now 1. If you execute this first, then your answer will be 1. Why? Because x3 of 1 1 is basically after this, x3 of 1 1 is basically this. And now you will ask this, x3 of this is 1, and then 1 1 is this. Now you will ask it to point here. Okay, you will do it wrong if you if you do not know about the chain assignment, and if you do this right first, then you will do it wrong, and then your answer will be 1, and 1 is wrong. This is wrong answer. Okay, so this is actually wrong way of evaluation in Python. Actually, you do not need to know anything. It is possible that you learn some things from the test series. To be very honest, I was also not aware about this. Okay, I was also not very much aware about that how these chain assignments are happening. When I was putting this question in the test series, at that time I got to know, because I have seen this in some standard university. At that time I got to know, the why the answer is 0, not the 1. Okay, and then I searched it, and then I got to know, okay, that is a reason. So it happens. Okay, and that is the reason I put this question in the test series. Okay, maybe the gate ask, so you should know it, right? I mean, currently you're doing it wrong or right doesn't really matter. Ultimately you are learning, that's matters, right? Okay. Now let's see this question. In this question they are saying that if this limit is equal to 5, then which of the following must be true? By the way, this limit is actually representing f dash 2. Okay, so they are saying f dash 2 is 5. So basically, if you're able to differentiate at 2, then you must be able to say that the function is continuous and 2 at 2. So function is continuous and differentiable. The derivative of f is continuous. So basically, they are saying, like, is the f dash 2 is also continuous? See, basically the function is continuous because you are able to find the differentiation. The function differentiable because you are able to find the differentiation. But the function itself, I mean, this f dash 2 is continuous or not? It is not necessary, right? See, I mean, it could be definitely possible. For example, this could be something like this, right? I mean, suppose let me give some example. Let's suppose, I mean, some function at x equal to 0 is, let's suppose, minus 3x square if x is less than 0, f dash x. Okay, I'm defining f dash x, 3x square if x is greater than or equal to 0, something like this, right? Is it differentiable at x equal to 0? Yes, it is differentiable. I mean, f dash 0 is 0, right? F dash 0 is 0. Differentiable at x equal to 0. But is this f dash 0, I mean, is this contiguous? The function is differentiable at 0, but is this f dash 0 contiguous or not? If this f dash x contiguous or not at x equal to 0, which is not contiguous, right? So you can say at x equal to 0, f dash x is not contiguous. Okay. See, here this f dash 0 is not the differentiation of this function. Okay. I mean, the differentiation of this function is actually f double dash. Okay, I'm not saying that function is differentiable but not contiguous. Okay, I'm not saying this. Okay, don't treat it like this. I'm saying there is some function, okay, which is not contiguous, which is okay. I mean, that's all I'm saying. I'm not talking about the differentiability of this function. Okay, I'm just saying that this function is not contiguous. But this function happen to be differentiation of some other function. So that function is basically that other function is differentiable at x equal to 0. But this function, which means the differentiation itself is not contiguous at x equal to 0. Okay, so it is definitely possible. So that's why A and B are true. I mean, the first and two are true, the third is false. So 1 and 2 are true. Okay, great. For third, I think the reason that they've written the derivative of fx continues, the existence of f dash 2 alone does not guarantee that the derivative of f dash is continuous. I mean, f dash 2 basically is there, right? So, but it doesn't mean it is contiguous. I mean, f dash 2 is there, I mean, which is basically, it is existing, which is 3. F dash 0 is basically, let's suppose 0 here, but it doesn't mean that it is contiguous also, okay? Let's solve this question. This question was related to Taylor's theorem. Okay, so they are saying that this is given to you the third degree Taylor polynomial for f about x equal to 2. They want to find out. So you can write this fx in terms of the Taylor series, which is basically, I mean, the formula is here. So it will be f2 will be f2 plus f dash 2 f dash 2 into x minus 2 plus f double dash 2 upon 2 factorial into x minus 2 square. So basically you just have to apply the formula, right? So if you apply the formula, you will be getting minus x by 2 minus x minus 2 whole square divided by 2 and so on. So basically B is the correct answer here. Okay. So you just have to apply the Taylor's formula here. Taylor series or Taylor formula is actually officially written in the GATE syllabus. So that is the reason we have given this question. Okay. They have officially mentioned the Taylor formula. Okay. Now let's solve this. On which of the following interval the function x cube plus x square minus x both decreasing and concave up? So by the way, for concave up, the double differentiation of the function has to be greater than 0, right? So for example, the function has to be something like this. Okay, at that particular point or in the particular range, the function has to be something like this. Okay, so whatever is the range is the answer. In that range, the function has to be something like this, right? Because concave up is this. But if it is decreasing also, so basically decreasing means it has to be there. It also has two parts, so it has to be of this part, which means decreasing means f dash x should be less than 0. So basically they are asking what is the interval for which these two conditions satisfy. For decreasing, f dash x less than 0. For concave up, this. Basically geometrically the function in that range will look like this. Okay, will look like this. Geometrically the function in that range will look like this. Here it is a concave property and also the function is decreasing. Obviously it is decreasing, right? And the value is decreasing. So basically geometrically the function will look like this. So I just have to find out that which of this is basically satisfying these two mathematically, right? See, these things I have covered in one of the video, which is like second derivative test and all. So here I told you that, for example, this is the concave up only, but increasing. Okay, this here I have shown you the part where it is concave up only, but increasing. Okay. Similarly, for concave up and decreasing, for decreasing, this is the region, okay, where where this is greater than 0. I mean, f double dash x greater than 0 in this region, and f dash x less than 0. Okay. So basically, for this function, you can find f dash x, you can find f double dash x, and then you can find in which these two conditions are being satisfied. For example, see here, if I just plot, if you just tell me, this will be basically the critical points here will be 1 by 3, and minus 1, right? Minus 1, 1 by 3. And from here, I will be getting equal to 0, minus 2 by 6, which is minus 1 by 3. Okay. Something like this. Okay. So these three are the points on which we can talk about. So if you take something which is basically, let's suppose, uh, greater than 1 by 3, right? Okay. So it will be positive. And if it is greater than 1 by 3, let's suppose 6, then it will be also positive. So f dash x is positive here, right? I mean, we want f dash x to be negative and we want f double dash x to be positive. Okay. So f dash x in this region is positive, but we want it to be negative, which is fine. Like, I will just find out the reason. So basically here also f dash x will be positive. In this region, okay, in this region actually, the f dash x is negative, right? In this region, f dash x is negative. And what about f double dash x? F double dash x will be, we want f double dash x to be basically positive, right? So if you check about f double dash x, there is only one critical point here, minus 1 by 3 for f double dash x. Greater than that, it will be positive. So I think here it will be positive. I mean, everywhere it is positive, but I'm just interested in the region where this is negative and f double dash x is positive. So this is the region where f double dash x is positive. Okay. Why? Because greater than minus 1 by 3, let's suppose x equal to 100. If you write x equal to 100, then everywhere else it is positive actually. Okay. But less than minus 1 by 3, if you write it, then it will be negative. Okay. So this is the common region, which is minus 1 by 3 to 1 by 3. In this region, okay, in this region, probably you can have the open interval if you are just avoiding the zeros. Okay, in this region, you can say both the conditions are satisfied. So minus 1 by 3 to 1 by 3 is the correct answer. So A is the correct answer here. Okay, let me just check the answer. Yeah, minus 1 by 3 to 1 by 3. So A is correct. Geometrically, I hope you understood that what I mean to say, right? For concave up, f double s x should be greater than 0. For concave down, okay, concave down, f double x should be less than 0, right? Which is something like this. Now here also there are two parts. In this region, you can say the function is increasing. So anyway, f double x is less than 0 for both of these parts, right? For both of these parts, f double x is less than 0. But you can talk about f dash x. F dash x is greater than 0 here, and f dash x, since it is decreasing, is less than 0 here. Okay. So this is the geometry. I hope you understood this. Now let's just talk about the next question. So this question is very interesting, and we will solve it very carefully, and I will just explain it everything, okay, about it. This question was of 2 mark for its own reason. You will get to understand that why this question was interesting. Let me just explain. So this question is basically saying that you have two sorted arrays. Suppose A and B are the two sorted arrays. So A is one sorted array, B is another sorted array. And see, these are the sorted arrays, right? And you want the kth smallest element in the concatenation of this. So for example, like A is one sorted array, it could have any number of elements. B is one sorted array, it could have any number of elements, right? The number of elements are actually given m and n, so which is fine. So they are saying that in the concatenation means that you want to basically merge them, and you want to finally find, I mean, out of all these elements, you want to finally find k the smallest element, right? And the algorithm is also given. And then they're asking to find out the values of p and q, and then also the time complexity of this algorithm. Okay. So see, this particular algorithm, I've actually asked from Berkeley. So this question I've taken from Berkeley. If you check page 3 of this link, it will show you. Yeah. So this question I've taken from here, and I basically made these some of these values at blank. And then also it is given at at another link of Berkeley at page 4, like the similar algorithm, divide and conquer algorithm, and so on. Okay. And see, yeah, I've also asked the same question. I mean, with the different language and with the completely different version. In Gate CSE also. Okay, so the almost same question, but with very different version. Okay, K is the smallest element in the concatenation of two arrays and so on. Okay, so I've also asked this question here. Now, there are many people who have basically commented about the question that this is a nice question and all. Like for example, I think, yeah, nice question. Okay, like this. So this question is good, and let's just solve this question without wasting much of the time. And here also at Gate CSE also I have given the solution of this question, and it was a little different. I mean the question was same, but in a little different style. So without wasting any of the time, let's just solve this question directly. Okay, let's see. So what they are saying, that you have two sorted arrays, and then you want to find out the kth smallest element in this sorted array, and some algorithm is given to you. Now, interestingly, we can solve this question without merging them and then sorting it. If I merge them and then sort them, it will be little you can say hectic or little time consuming. Obviously, the time complexity will be n log n or something. But in worst case, actually, the time complexity is much lesser than n log n if we apply some smart technique. Okay. So what is that smart technique? Let's just see. Suppose this is A and this is B, right? Now. Um, there could be any number of elements here, but let's suppose basically one of the element here is 7 and one of the element here is, let's suppose, 12. Okay, suppose what we do, we want to find out the kth smallest, right? Kth smallest. Suppose we find out a k by 2, a k by 2 and b k by 2. So we are going to find out a k by 2. Let's suppose this is a k by 2 and this is b k by 2. Okay, and here in this case, like this bk by 2 is greater than ak by 2, so which is fine. So basically the algorithm work like this. I mean, you do not have to think about the whole algorithm. They have given the partial hints, and like lot of the hints they have given, and then you have to solve based on that, right? So this is ak by 2, this is bk by 2, and then suppose this is greater. Now you want kth smallest, right? Now just imagine how the concatenation of these two array will look like. See, see, the concatenation of these two array will look like this. I mean, whatever is the concatenation, okay, you will be having wherever you are having 12, wherever you are having this 12, right? Before that, obviously, all of these must be coming, and all of these must be coming, right? So at least k by 2 elements, this and k by 2 minus 1 element, something like this, right? So k by 2 minus 1 elements or something like this. I mean, k by 2 elements, you can say. So basically you can say that this 12 must be at least at kth position, right? I mean, why I'm saying at least, because it could be possible that these numbers could also come here. I mean, you never know. Like these numbers could be like 8, 9, 10, like this, right? These numbers could also come here and 12 gets shifted. So basically, 12 must be at least case position. It could be here also. I mean, it could be later on also. Or in other words, you can say before that at least, I mean, almost like k elements must be there, right? So the thing here that I want to convey is that uh, that there is no point in considering, right, these elements. See, if we are calling it x, okay, if we are calling it y, so here in this case x is less than y. Okay, x is less than y. Now you see here that we are going to consider only now. I mean, we are going to have the recursive call, and then we are going to discard. So let me just tell you that what we are going to do. This is very nice algorithm. Let me just tell you what we are going to do. If x is less than y, which means, I mean, this is just a case. I mean, you can have x greater than y also. The things will work with the symmetricity. So don't worry about the other case. Like just focus on this case. The thing I'm saying, if you want to find out the kth smallest, then there is no point in considering these elements for the next iteration. That is the biggest observation here. Why? Because whatever is the number of elements, this won't matter, because either 12 is the kth smallest, right? Or maybe if some of these elements are coming, right, maybe 12 gets shifted, and then maybe before 12 basically the kth smallest will be there, right? I mean, this chunk which is going to copy here as it is no longer useful to me, right? So kth smallest cannot be here. You getting my point? Similarly, interestingly, this chunk is also not useful to me. Why that is the case? Because see, it may be possible. See, it may be possible there could be very large numbers here. I mean, this may be possible. I mean, that's fine. But this chunk is also not useful. Why? Because this 12, right? See, this chunk will be coming here and this chunk will be coming here. The thing here is that this 12 will be at least at kth position. I mean, this will be at least, this is the most important observation, at least at kth position, right? So either kth smallest is this. If this is not the kth smallest, then what is the reason that it is basically getting shifted here? I mean, it is basically k plus one, k plus two. I mean, what is the reason that that this 12 is, I mean, getting shifted? Because of these, right? Because of these are coming. If these are not coming, then 12 is kth smallest, isn't it? If these are not coming, then 12 is kth smallest. If these are coming, then only 12 can shift. Which means if these are coming, then anyway these have to come after these, right? I mean, after these obviously these has to come. So basically you can say at kth is smallest, so one of this might be there, right? I mean, either these, I mean, basically these or these, right? So basically the thing here is that if either 12 is kth is smallest, if 12 is not kth is smallest, then the only reason it is not kth is smallest is because of these, some of these are coming, right? Maybe here, I mean, they can come anywhere, but they have to come after this. I mean, this have to come like a chunk, right? I mean, it cannot be like the case that they can come before that, right? I mean, basically continuity must be there. After these elements, only these elements can come in the sorted array, right? Because A is sorted and B is sorted. See, what I'm trying to say is that this is A, right? This is B. Now here, let's suppose this is 12. This is, let's suppose, 7. Here, let's suppose before 12, very small numbers are there, 0, 1, 2, like that, right? I mean, doesn't matter. Very small numbers could be there. But here, let's suppose very large numbers could be there. Okay, 4, 5, 6, something like this. Okay, something like this. Actually, doesn't matter. Basically, what I'm trying to say is something like this. If this is at k by 2 position, and if this is at k by 2 position, and in this case, this number is greater, right? So 12 will be coming anywhere in the sorted array. Let's suppose here. Now, before that, all of these must be coming because these are lesser than 12, and all of these must be coming because these are also lesser than 12. So before this, I can say almost like, I mean, 12 could be at least at kth position, right? I mean, you can say k by 2 these and k by 2 minus 1 these, right? Something like this. I mean, I'm not worried about minus 1 plus 1, but yeah, almost like k elements must be there, right? Almost k elements must be there, right? And this is at kth position, and kth smallest is this. So this is the answer. This is one possibility. Another possibility is that this is not exactly at kth position. And what could be the reason? Maybe some of these are coming. Maybe some of these are coming before that, right? Then this is not exactly at kth position. And some of these are coming, could be like this could be 8, 9, and this could be like very small number like 1, 2, 1, 3, something like this, right? I mean, this could be come very first, and but this is coming, okay? This is coming. So basically the thing is that this might get shifted. Maybe some of these are coming, right? And if these are coming, right? If these are coming, then these will be occupying. I mean, see, the thing here is that at kth position, these will be occupying, right? These will be occupying the kth position. Okay, some of these, or maybe like it depends on maybe if these are larger, these could also occupy. So basically, the thing here is that I will never need these numbers to consider. Similarly, I will never need these numbers to consider. Okay. So whenever I'm doing the recursion, I can say let me start the recursion from k by 2 plus 1, or k by 2, yeah, you can take k by 2 plus 1 to k from A, and no, from B you can say 1 to k by 2 minus 1 or something like this, right? Now, initially you wanted to find the kth largest, or sorry, kth smallest, right? But here, since you are discarding k by 2 numbers before the kth, I mean, in the kth smallest, you are already discarding these k by 2 numbers, right? Since you are discarding these k by 2 numbers, so that is why, let's suppose you are discarding the j numbers or x numbers. So instead of k, you want to find k minus jth smallest now, if you're discarding these j numbers. Okay, so instead of k, you want to find out k minus jth smallest, because some of these numbers are all not there. So basically you can say that that those positions are not there. So basically now instead of k, you want to j value is k by 2, so basically k minus k by 2, which is k by 2 smallest. Okay, now instead of k, I want to find out k by 2 smallest, right? So I will be discarding one part of a, one part of b, and now I will be finding k by 2 smallest. So see here, left part of a, right part of b, I will be discarding. Okay, and instead of k, I will be finding k by 2 the smallest. Initially I wanted to find k the smallest. Now I will be finding k by 2 the smallest. Okay, this is interesting. Again, I will not be finding k the smallest, right? Why? Because I have already discarded some, let's suppose, j elements, okay, which are lesser than k by k the smallest. So now I will be finding in my new recursion k minus j the smallest, right? And similarly, this will follow from the symmetricity. And the same question I have given here in gate CSE also. Okay, in gate CSE also, and there is a like algorithm, the similar way of algorithm, the same, almost same kind of question I have given. Okay. So now you can see by the recursion that always I'm doing from k, I'm going to k by 2 and then k by 4, like that, right? So from here you can say the time complexity is log k. Okay, log k. But they're asking the time complexity in the both of the option in terms of log m and log n. So since k is basically as good as m or n, so it could be log m plus log m. Okay. See, this question I'm not made up this question. This question I've taken as it is from Berkeley University. Okay, from this PDF. And here they are saying the time complexity is log m plus log n for this particular algorithm. Okay, this exact same algorithm they have given. Right. So don't worry if there is like too much problem in understanding just one question. It was just one question. I hope you are learning something new from this question. Okay. Just the new thing that you can learn is that you can discard one of the segment of the array. Okay. And then you are recursing for k by 2. So that's why the time complexity is log k. Okay. Because every time you are doing divide by 2, divide by 2, divide by 2. So hence the answer you can say that if you are going for this, then yeah, I think B is the correct answer. X is less than Y. Okay, so here I'm discarding. So B is the correct answer, and B and C, right? So answer I might have written here A and C. Just a second. And option A, if X is greater than Y. If X is greater than Y, then K by 2. Yeah, sorry. Yeah. So basically, if X is greater than Y, then I will be going for. I'm actually going for the first half. Okay. So if X is greater, if X is less than Y, then I'm going for the second half of A. Okay. If X is less than Y, then I'm going for the second half, which means A, right? Then I'm going for the second half of A. Okay, that's fine. So basically, this X is less than Y is actually written at the next line here. But I think in my algorithm that I made here, X is less than Y I have written first, which is okay. Okay, that's why I got little confused. But yeah, for X is less than Y, I'm going for the second half of A. So uh, that's why A is the correct answer. For X is less than Y, I'm going for the second half of A. Okay, great. So I hope you understood this question. Now let's just move to the next question. So here in this question, they are saying consider the binary tree whose pre-order and order traversal both are A, B, C, D. See, pre-order is what? Pre-order is what? It is root, left, right. In order is what? In order is left, root, right. Okay. Now they are saying both are basically same. Okay. How could both be same if left is not there? Right? If left is not there, then root and right, and this is also root and right. If left is there, then there will be a problem, right? I mean, this will be different from this. So just try this out. That for ABCD, just write like this: AB, C, D, E. Just find out the pre-order, which is a root, left, right. So root is A and left is not there, so right. So we will go to the right. For the right also root, left, right. So basically this will be the pre-order. What about in order? For the in order, you need to find out left, root, and right. So left is not there, root is A, and then go to the right. For the right also, left is not there, root is B, and go to the right. Okay. Then similarly, this will be the pre-order in order. Okay. So they are saying what is the height of this tree? If the height is the basically maximum number of edges from path root node to any leaf node. Okay. So basically 1, 2, 3, 4. 4 is the height here. Okay. So answer is 4, and this is the tree. Okay. This is the tree. This was easy question. I hope you got to understood this. The key idea is that both will be same whenever left is not there. Okay. Whenever left is not there. Let's see this question. In this question, they are saying, consider an initially empty hash table with 32 buckets. The hash table does not resize in any of the scenarios below. Each subpart is independent. That is, hash table starts empty for each case. Do not assume anything about how the items are distributed across the buckets. After inserting the elements into the hash table, select all the correct statements. So 32 buckets are there. After inserting 16 items, the minimum possible number of the buckets, the minimum possible number of the items in bucket 0 is 0. It is possible, right? I mean, in bucket 0, there is no mapping, so it is definitely possible. After inserting 16 items, the maximum possible number of items in bucket 0 is 16. Yeah, everything is mapping to bucket 0, right? This is also possible because the maximum they are saying. After inserting 16 items, the bucket 0 must contain at least one item. No, it is not necessary. I mean, they may be containing minimum could be 0, right? Minimum could be 0. If 4 strings are inserted and each bucket is implemented as an unbalanced binary search tree, the worst case total number of string comparison required for all insertions is 6. So in worst case, let's suppose everything is mapping to one bucket and the bucket is basically not having chaining. Okay, they are basically implementing the unbalanced binary search tree. So for 4 numbers, let's say A, B, C, D. I mean, A could be one string, B could be. So for A, there is no comparison. Okay, initially A, there is no comparison. For B, there will be one comparison. Okay, one comparison for B whenever B is coming. For C, I want to have maximum number of comparisons, so I will compare C with both, right? 1, 2. For C, there are two more comparisons. For 3, since I want to have maximum number of comparisons, I will be comparing this D with A, B, C all. So basically 3 more, right? So 6 more, like 6 total comparisons. So yes, this is true. So A, B, D are the correct answers here. Okay, great. Now let's solve this question. This question was related to machine learning, and initially this question was basically having a little different language, which led to some confusion. So I basically corrected that language as the original source, and then this is the question. Okay, so they are saying that you are having a perceptron and linear regression. So if you are using the perceptron, basically, then using the perceptron, you apply this formula w plus eta yx, right? Now, eta value is given as 1 by 2. And if you do this, then they are saying that W is unchanged and the length is halved. So basically, they are saying that W new basically becomes W by 2 only. Okay. Which is equal to W plus eta is half Yx. Right. Okay. So from here, you can say that this is minus W by 2 and 2 get cancelled. So Yx is minus W. Right. From here, x equal to minus W uh, minus yw. Basically, it will be 1 upon y, but 1 upon y is same as y if y is basically minus 1 plus 1, right? Okay. So from here, x is coming out to minus yw. Now they are saying that you now instead of perceptron, you consider the linear regression on the linear regression trained on the levels minus 1 plus 1 and do the classification. What is the loss for the same example x if we use the linear regression with the weights w? Okay. So basically, a linear regression uses this by minus w transpose x, right? whole square. And this is what linear regression uses. So I think from here we can find out the W transpose X. Okay, if X is this, then W transpose X is basically, you can multiply with the W transpose, it will be like this, right? So linear regression will give you Y minus, and minus minus will be plus. So W transpose X is this, right? Okay, which will be Y, you can take common 1 plus Y square. Okay. Yeah. So what will be the loss for the example X if we use a linear regression W by? Yeah. So basically this is the whole square, right? This is the whole square, and Y square is anyway 1, right? Y square is anyway 1. So this will be the answer. Okay. So C is the correct answer here. This was an easy question. Probably there was some confusion in the language, so that's why seemed to be high. It seems to be a little difficult question, but ultimately it was an easy question. So let's solve this question. Here they have given some data, and they are saying that you are mapping this data to some 6 dimensional space like this, and the weight vector is also given. So you're using the perceptron, and perceptron is using this loss function where there's a maximum of, see, if the perceptron is misclassifying something, in that case, this will be negative in case of misclassification. So with the minus, it will be positive, right? If perceptron misclassifies, then this will be negative, and with the minus, it is positive. So yeah. So basically, if perceptron is misclassifying, then you will take the positive number. Perceptron is classifying correctly, then you will see that okay, this is basically positive. So ultimately, this is negative. So loss is 0. Okay, maximum is 0. Okay, so I think this is easy question. You have your X, then you can basically, given the feature transformation, you can do the feature transformation, which means the feature transformation is saying 1, x1, x2, x1, x2. Okay, something like this. So you can find out your, given the X, you can find out the phi X, right? Which is the feature transformation. So so basically 1 is as it is, x1, x2 are as it is, right? So 1 and x1, x2 are as it is. After that, x1 into x2. So here it is 0, right? Here it is 0. So the first three are basically easy. First three are same. Now, fourth one basically x1, x2, which is 0 here. Then x1 square, x2 square, right? X1 square is 1 and 0, right? Here it is minus 6. Then x1 square is 4, x2 square is 9, like that, right? So you can write phi x. And now basically you can basically have a w into phi x. W is given to you, and you can just dot product with the w. W must be your 3 and 3 6 dimension. So this w is given to you, and they are asking with this with respect to initial w only. This w is given minus 2 minus 26 14, and the correct level is basically also given plus 1 minus 1, like that, right? Since this is coming out to be negative, right, and the correct level is positive, yes, there is a loss, right? There is a loss, right? So you can say, in other words, if you just do the multiplication of this is negative, right? So there is a loss. This is positive, there is no loss. This is negative, there is a loss. In other words, if the sign of this are mismatching, then there is a loss, right? So there's a loss here, and loss is basically the absolute of this. Or in other words, you can say that minus of both of these multiplication, okay, which is basically 2, okay, or the absolute value of this if there's a loss. Here similarly, the absolute value of this, which is 14. So this loss is 2, this loss is 14. So total loss is 16. Okay. So 16 is correct answer here. I hope you understood this question. Now let's just solve this question, which was really a nice question, and it was related to the thing that if we are able to understand that how these W1, W2, W3, or the weights are basically behaving with respect to the logistic regression model. So they are saying that suppose you want to classify into dog or cat. Okay, cat is basically having class 1, and these are the three features: x1, x2, x3. X1 is the height, x2 is the length of whiskers, and x3 is the thickness of fur. We perform the standard normal scaling. Okay, so they are saying that normalization you are doing, the standardization you are doing on the training feature, so that the mean is 0 and the standard deviation becomes 1. We train the logistic regression model to determine the probability of this. Okay, probability of y being 1, which means the class is cat given that x comma w. So this has the very standard formula, which is this, right? Okay. So in the logistic regression, you already know the formula, right? Now they are saying that our classifier learns that cat have the lower height and longer whiskers than dog. So they are saying for the cat, the height, which means x1, okay, this should be lower, and longer whiskers. Longer whiskers means the feature x2. Um, I mean, in terms of the numerical value, I will not be writing longer. Let me write higher, okay? Because ultimately, and let's suppose this x2 is numerical, right? Okay. So longer whiskers, and then they are saying while the thickness of fur is not relevant to the classification model, which means they are saying x3 is not relevant to the model. Okay. So for the cat, these are the like specifications of the cat. Okay. X1 must be lower, x2 must be higher, and x3 actually not relevant. Right. Now they are asking the values of w1, w2, w3. So basically we already know this formula. Now we want for the cat, we want a probability of y being 1 to be obviously larger, right? We want this probability to increase. For the cat, we want this probability to be increasing. If we want this probability to increase, then what will happen? So basically, this will increase whenever you might already know probability of y equal to 1. Let's suppose x w. It is 1 upon 1 plus e minus w transpose x. I mean, if this w transpose x, whenever this w transpose x increases, the probability of y equal to 1 increases, right? Why? Because if this is increasing, this is decreasing. If this is decreasing, if since it is in denominator, the whole thing will be increasing only. Or in other words, whenever the W transpose X, greater than 0 become more and more greater than 0, the probability of Y equal to 1 keeps on increasing. So basically my ultimate aim here is to increase this, right? Because I want the cat to be classified very much correctly. So I want to increase this. Now there is like two ways, like let me just explain one of the way and then I will explain one more way. So uh, see, you want the X1 to be lower, right? Or in other words, you can say whenever x1 is increasing, right? This should belong to dog, or the probability this should be decreasing, right? This, I mean, probability y equal to 1 decreasing. This is what we want, because x1 is lower for the cat, right? So whenever x1 is increasing, at that time it will be dog. At that time you want the probability y equal to 1 to be decreasing. That is possible whenever the multiplicative factor that you have here should be negative. Then only the whole thing, right? I mean, whenever x1 is increasing, you want w transpose x to also decrease, because w transpose x and y equal to 1 are directly proportional, right? So whenever x1 is increasing, you want the w transpose x to decrease. I mean, ultimately you want the probability to decrease. So basically you want the w transpose x to decrease, or in other words, uh, w1 x1 you want to be decreasing, right? Because x1 is lower for cat and x1 is higher for dog, right? So whenever x1 is increasing, you want that to shift to dog. So which means you want I mean, you want the probability of 1 to decrease, which means probability of y equal to 1 to decrease means w transpose x decrease, because both are same. So you want this to decrease, which is possible whenever w is negative, isn't it? It is possible whenever w is negative. Have you understood this? Let me know. Okay. Similarly, if you talk about x2, right? See here, x2 is higher, right? So whenever, just think in the opposite way, right? Whenever x2 is decreasing, you want to shift to be dog. Okay, you want to give to dog, or maybe you can think in the same way. Maybe the x2 is increasing, right? Then you want to give it to cat, which means the probability want to increase, which means you want w2 x2 to increase. W2 to x2 you also want to increase, which means w2 should be greater than 0, right? Then only whenever x2 is increasing, then only w2 x2 will be increasing if w2 is greater than 0, right? So W1 less than 0, W2 greater than 0. Third is which is like X3, it is not relevant, right? So if it is, I mean, it is not relevant for the cat. So which means like W3 is basically almost 0 because it is not much relevant feature. So W1 is negative, right? W3 is 0 and W2 is positive. So this should be the order. W1, W3 and W2. Yeah, C is the correct answer. Understood? It was a good question. I hope you understood. So this was just one of the way to think about it. You can think the same question in the other way with respect to the the thing that they have given, that you have done the normalization, mean, zero and all, right? So basically, if you do the normalization, in that case, if something is already lower, okay, lower than average, lower means like there are only two people. If lower, these things are always relative, right? Relative in the sense that if I'm saying something is lower, then should be lower than the dog, right? So overall, it is basically lower than the average things, okay. So x1 automatically, okay, if you are doing the standardization, or if you are doing the normalization, then x1 will automatically be negative, okay. So after normalization, since it is lower, okay, so you can say after normalization, whenever there is a cat, okay, for cat, x1 will automatically become negative. Okay, because something is lower than average, and then let's suppose 5, and then you are subtracting the average. Let's suppose average 10. Obviously, it will be minus 5, right? Right? And it will become negative. Okay, after normalization. This is, you can say, method 2. Okay, method 2. What about x2? X2 will be positive. What about x3? Actually, x3 is not relevant. Like, I don't know whether it is high or not. So it is not relevant, right? Not relevant. Okay. See, I hope this method is clear to everyone. This was the method 1, where I'm not considering the fact that you're doing the normalization or not, okay? But you can consider with respect to the normalization also. So, what do you want? You want that, okay, if x1 is negative, then ultimately you want that if x1 is basically, you know, uh, okay, irrespective, okay, let's not think in that way. Like, let's not think that whether the x1 decreasing or increasing. So basically, in this method too, we will think in terms of the that x1 is being negative, positive, or like that, right? So method one was related to whether x1 is increasing or decreasing. So basically, the height will become negative. I mean, x1 will become negative, and you want I mean x1 to you want x1 to be lower, right? Which means like you want more negative, right? I mean, you want this x1 to be more negative, which means that if x1 is more negative, then probability should be increasing. That could happen whenever w1 is less than 0, right? You want x1 to be as negative as possible, right? So that the probability keep on increasing, which is possible whenever w is less than 0. If w is greater than 0, then f and x1 is more negative, then the probability will even decrease, right? So that's why w1 is less than 0, and you want this to be as positive as possible. I mean, as higher as possible. So which means whenever x2 is more positive, you want w transpose x to increase. I mean, probability to increase, right? Which is same as w transpose x, which is basically w2 greater than 0, and w3 doesn't matter. So w3 is almost 0, right? So that's how also you can find out these symbols. I mean, these signs. I mean, that's okay if then after normalization, if you are considering, I mean, before normalization also, you can solve this question. Okay. So I think this was a nice and cute question. Like, not very tough, not very easy, but yeah, some logical question from logistic regression, right? Okay. Now let's solve this question. This was, I think, easy question only, and here I'm just asking mean square error. So the number of points in every case are fixed. I think, like, I mean, 1 2 3 4 5 6 7 8, and here these are 3 3 6 7 8. Yeah, number of points are seems to be fixed. So here the mean square error in case of A, see the grid is given to you. So basically this will be the 1, 2, 3, right? So this distance, which is basically predicted by is whatever is this, and absolute y, basically the difference between this is 3 square, right? Which is 9 divided by total number of points. I mean, for all other points it is 0, right? For all other points it is 0. So 3 square divided by total number of points, which is 9, which is 8, right? Okay. Here it is 2 square plus 2 square, which is like 4 plus 4. Okay. So here it is 9. Here it is 2 square plus 2 square, which is 8. Here it is 1 square, 1, 2, 3, 4, 5. Yeah. 1 square plus 1 square plus 1 square plus 1 square 5 times. So it is 1 square plus 1 square plus 1 square plus 1 square plus 1 square, which is 5. So minimum is for C, and then I think for B, then I think for A. Okay. Yeah. C seems to be the correct answer. Let's just check. Yeah. Okay. These are the values that we have. Now let's move to this question. So for this question, they are saying that they are basically asking whether lambda equal to 1 is the eigenvalue or not. I mean, lambda equal to 1 is the eigenvalue, lambda equal to 1 is not the eigenvalue, lambda equal to 0 is the only eigenvalue, all the eigenvalues are strictly greater than 1. So basically the question is intending to ask whether the lambda equal to 1 is the eigenvalue or not. So this is called the block matrix. I mean, these matrices are basically these blocks are itself by the block the matrices, and this block matrix term has been used in Gate DA official syllabus. Okay, I mean in the syllabus itself, they have in the linear algebra they have written the block matrix. So that's why we have put this question. Okay, so the one of the very nice property here is that for the diagonal block matrix is that upper triangular, here you can say upper triangular matrix, is that the eigenvalues of these are also the eigenvalues of A. Okay. So you can say you can find out the eigenvalues of B11. If you find it out, then you will be getting 1, comma. I think these are the two eigenvalues. This is question number 46. So yeah, 1 comma 4043. Okay, you can find out the eigenvalues 4043. Actually, this is bit symmetric matrix also. For the symmetric matrix, there seems to be 2 by 2. There seems to be some other method. You can say a plus b and a minus b, because the determinant is basically a square minus b square, and the product of eigenvalues also the determinant. So this will be a square minus b square. If you factor it out, it will be a plus b and a minus b. Okay, and the summation will be the trace. So which means it is 2a. If you just sum these, it is 2a. I mean, this seems to be a shortcut to find out the eigenvalues, but obviously you can't remember the shortcut always. So that's fine. Basically, you can find out those eigenvalues. This is 1 comma 4043. So the eigenvalue of B11 must be the eigenvalue of A. So hence 1 is eigenvalue of A also. And these things we have covered in the course. We have already covered the block matrix. We already told the properties that the if it is upper triangular like that, then eigenvalues of every of this block is also the eigenvalue of A. Okay, so A is the correct answer here. Now let's solve this question. This was related to one-dimensional loss function. So suppose you have some loss function, one-dimensional. This is a case of one-dimensional, and now they are saying the minimum is at W star. Okay, this is the minimum, and at iteration t you are at wt, okay, which is greater than w star. So basically, since it is just one dimensional, so if it is w star, then don't worry about wt. I mean, it must be here. Okay, so it is very easy question because w2 must be here. So they are saying that w2 wt must be greater than it is given that wt is currently greater than w star. Okay, must be here. Since it is a loss function, which is a convex loss function, which means the shape will look like this. Okay, so obviously here you can say the function is increasing, right? Which means the derivative of the loss function, okay, del L at point of wt must be greater than 0, right? Now since you have to go to the minima, so you will be going like this. So wt plus 1 will be here. Wt plus 1 will be here, which is lesser than Wt, right? So Wt plus 1 will be lesser than Wt. So Wt plus 1 must be lesser than Wt, and this is okay, this is greater than 0. So I think A is the correct answer. Okay. So we have used the gradient descent, and yeah. So basically, this is because I'm moving from Wt towards W0 or W star. Okay, I'm moving towards the W star. So basically, Wt plus 1 must be somewhere here. Okay, assuming that there's not too high jump. Okay, if it is too high jump, then it could be here, which is also like lesser than. I mean, you will be moving in this direction anyway, right? Which is lesser than Wt. I mean, you could move here also, but it's not a good idea. You could move too far. Okay, you could move here, but it is basically lesser than Wt only. At this current position, obviously the gradient, since it is increasing at this position, gradient must be zero, greater than zero. Okay. So I hope you understood this question. It was easy question only because it was one dimensional case. Now let's move to the next question. So in this question, they're asking about the leave one out cross validation error for 1NN and for 3NN. Leave one out means you mark this as a test case and then you train on the remaining. Okay, I mean there is nothing to train in case of nearest neighbor, but yeah, like the officially it is basically you take it as a test, and I mean take one of them as test and then train on the remaining. So basically, if you take this as test, basically you need to apply 1NN and 3NN. Let's just first talk about 1NN, right? So the nearest is basically minus only. See here there is no problem, right? I don't think there is problem in 1NN or there is 3NN. I mean in this case there is no problem in 1NN, there is no problem in 3NN, right? But here for all of these positives there is a nearest is negative, right? So that's why there is a problem in 1NN. I mean you will see that okay, you will mark this as negative based on this. So there's a misclassification. So all of these positive there's a misclassification, plus there's a misclassification for this also. I mean whenever you are marking this as test, right? Because nearest is basically one of the positive, so misclassification for this also. So there are five misclassification in case of 1NN out of all 10, right? I mean 10 including this. There is no misclassification here in 1NN, neither in 3NN, right? But in case of 3NN, in case of 3NN, whenever you are marking, let's suppose you're marking this is as test, then you will be checking three nearest. Out of two are basically positive, so you will be marking it positive, right? So that's why there is no problem for any of these positive. Okay, in case of 3NN. But there is a problem for this negative because if you take the nearest neighbor, then it will be positive. So the negative, one of the negative will get misclassified, which is this out of all 10, right? So misclassification rate will be 5 by 10 and 1 by 10. 5 by 10, 1 by 10. So B is the correct answer. Okay. So actually this was easy question, but we have put it in 2 marks because some of the people might be finding it tough. So that's why we put it in 2 marks. Okay. Let's now move to the next question. So here they are saying that X is a matrix of shape dy n, and then is SVD is also given. So basically X equal to U sigma V transpose. I mean they've given S, but I'm taking sigma because sigma is more popular. And A is a matrix which is X transpose. Okay. So basically A will be U sigma V transpose into X transpose means V sigma transpose U transpose. V sigma transpose U transpose. Okay. Which will be same as U since this is orthogonal matrix. Okay. So that's why this will be identity matrix. So U sigma transpose, and sigma is actually diagonal matrix. So sigma and sigma transpose are same. So it will be sigma square U transpose. Okay. So this is A. This is A, which seems like a eigenvalue decomposition, but that's fine. I mean, this seems like a eigenvalue decomposition of A. Now they're saying the eigenvalues of A are the singular values of X. Okay, see, these are the eigenvalues of A, right? I mean, the sigma squares are the eigenvalues of A. But the singular values of X are like sigma 1, sigma 2, right? But here, the eigenvalues of A are sigma 1 square, sigma 2 square, like that, right? So that's not exactly true. Actually, the eigenvalues of A are the squares of the singular values of X. Okay, so see here that the eigenvalues of A will be this, right? Which are like squares of the singular value, not the singular values themselves. So that's why statement 1 is false. Okay. What about statement 2? Statement 2 is saying A is PSD, positive semi-definite. That is, all eigenvalues of A are non-negative. So that you can easily see that all the eigenvalues of A are non-negative, right? I mean, the eigenvalues of sigma square, which are obviously non-negative. So that's why this is true. Okay. And anyway, like any matrix which is of this form, which is like XX transpose or A transpose, you have other ways to prove also. Like that is always PSD, which means like any matrix. Let's suppose XX transpose. Okay, then if you want to prove that A is phd or not, the way we are making A is basically it is actually phd only, which is positive semi definite. You can multiply z transpose z like this, then z transpose into x, this will be nothing but x z transpose. Okay, I mean this will be x z transpose whole transpose. Okay, so if you open this up, sorry, this will be, I think, um x transpose z whole transpose, right? If you open this up, it will be z transpose x. So the first two things, okay, could be x transpose x, x transpose z. So x transpose z into x transpose z, it is the length of x transpose z square, which is obviously greater than equal to 0, right? So basically, you can prove in multiple ways. I mean, you can just expand this x transpose to be like this, and then you can easily check that okay, eigenvalues are greater than equal to 0. Okay, or you can prove like this also. Okay, there are multiple ways to prove it. So B is actually true. The eigenvalue decomposition of A is also the SVD of A. This is interesting. So see, the eigenvalue decomposition of A was U sigma square U transpose, right? And if you have noticed that the way we are making A is basically XX transpose. Okay. So what is A transpose? A transpose is also XX transpose, which means A is symmetric matrix. Okay, it is symmetric and also positive semi definite, right? It is symmetric matrix, positive semi definite. So if A and A transpose both are same, then whatever is the you can say SBD of A. Okay, maybe let's suppose, I mean, you can have some other matrices, need not to be U and B. You can have P and Q. Let's suppose P sigma Q transpose or whatever. Okay, let me just take U and B because it is more familiar. So don't worry, like I'm not taking the same U and V. Basically, I mean whatever is the SVD of A, right? The if you take the A transpose, then what is the SVD of A transpose? If you take the transpose of this will be V sigma U transpose, right? So since A transpose are same, so the SVD also must be same. This must be same as U sigma V transpose. So basically, for this symmetric, since it is symmetric matrix, that's why left and right singular vectors must be same. Okay. For the symmetric matrix, left singular vectors and right singular vectors are actually same. Okay. So actually, we want to prove that the eigenvalue decomposition and the SBD both are same here. Okay. So how to prove it? See, you can say like this: A transpose will be the eigenvectors. Okay, left. I mean, this will be if you check the left singular eigenvectors, then you will be finding using A transpose, and similarly using A transpose A, you will be finding either left or right. Okay, uh, using for the left singular vectors, you will be finding A transpose. For the right singular vector, you will be finding A transpose A. Okay. Now since they both are same, okay, I mean basically they both are this A transpose is also symmetric matrix. So what I'm trying to say, let me go to the next page and let me just explain. So see, for any matrix A, okay, its eigenvalue decomposition will be something like this. right? And its you can say its singular value decomposition will be something like this. But if it is symmetric, in that case, u and v are same actually. Okay, if it is symmetric, in that case, u and v are same. Okay, so it turns out that for symmetric matrices, that q, u, and v everything is same. Okay, which means this is also uh, q sigma u transpose. Okay, here these are basically the eigenvalues. You can write the eigenvalues in some other way. For example, this. If it is symmetric, then it will be like this. Okay. Now, this lambda, I mean the eigenvalues and singular values will also be same for the matrices which are, you can say, symmetric and like the positive definite, okay, positive semi-definite, which means, see, the singular values are always greater than or equal to 0, right? But eigenvalue need not to be greater than or equal to 0. So in general, basically for symmetric matrix, you can say this is true for the symmetric matrices, okay? This is true for symmetric matrices, right? But let's suppose if the eigenvalues, okay, but let me just first complete this. So basically this is true for symmetric matrices. Here the singular values will be absolute eigenvalues, okay, something like this. So this is true for every symmetric matrix, right? But on top of the symmetric matrix, if you already know that eigenvalues are greater than or equal to 0, okay, if so it is additional condition. If lambdas are greater than or equal to 0, in that case, SVD, singular value decomposition, this I mean this singular value decomposition, basically this will be same as eigenvalue decomposition. In that case, this basically exactly equal to lambda. Hence SVD is equal to eigenvalue decomposition. So if your matrix is symmetric and positive semi-definite, right? Then this is true. So what about the matrix that they're asking? They're asking for A, right? So A is obviously positive semi-definite, right? I mean, we have already seen this, and it is symmetric because of the way we are constructing. So that's why this is true. Okay. So you can say that if your matrix is symmetric, so EVD, eigenvalue decomposition, and singular value decomposition, same if if matrix is symmetric and positive semi indefinite, right? So in that case, EVD and ISVD will be same. So hence, this is the correct option. Now in the last option, they are saying that x can be a vector x can be represented as a linear combination of last d minus k columns of u. That is this. Then it lies in the null space of X transpose. Okay. So basically, they are asking about the null space and other spaces. So let me tell you that in singular value decomposition, okay, you have this A, right? And then you can write AB equal to U sigma. Now, basically, you can represent this, this setup like this, that AB1 equal to sigma 1 U1, AB2 equal to sigma 2 U2, and then the last, I mean, till rank it will be till R, it will be like this, and then last vectors will be like this, right? Okay, so you can say U is in the column space, and these V's are in the null space. Okay, so these V's basically, uh, just a second. Yeah, so these U's are in the column space, and then these V's are in the null space. And since the null space or the column space dimension is R, so that's why row space dimension must be also R. Okay, and these are perpendicular to the null space, right? I mean, row space is perpendicular to null space. So that is the reason that these will be in the row space. Okay, and these are the column space, and column space and left null space are perpendicular. So that is why these will be in the left null space, right? So basically, based on the dimension, you can say that if this column space dimension is basically R, so row space dimension must be also R. And we have actually explained all of this thing in the lectures, that SVD can give you the all four fundamental spaces, right? Column space, row space, null space, left null space. Okay. So that's why you can clearly check that this option is also true. Just a second. So where it is? Yeah. So this option is also true. So, what are the true options? So, basically, I think only option A is false and B, C, D, yeah, all are true. Okay, great. Now, let's move to the next question. Okay, this was interesting question. So, let's just see what they are saying in this question. So they're saying that u1, u2, u3, v1, v2, v3 are the vectors in R4, and u is the span of this. Okay. I mean, they're not saying that these are linearly independent or not. U is just the span of this. It could be possible that one of them are linearly dependent or something like this. V is the span of this. Consider the following scenario. If the dimension u intersection v is 2, then the dimension of u is 3. So basically, they are saying that there are two subspaces U and V, okay, from R4, and if the intersection dimension is 2, then a dimension and the dimension of U is 3, then these are linearly dependent. So let me just go to the next page. Let me try to explain what they're saying. See, they are saying that if U dimension is 3, okay, so suppose this is U. I mean, this subspace is U. Dimension 3 means they are having three linearly independent vectors, okay. Suppose this is having three linearly independent vectors, and U intersection V is 2, okay. So which means there must be, okay, V must be something like this, okay. V must be something like this. Wherever is the V, it must be having two vectors coinciding with U, okay. Now v1, v2, v3. So are linearly dependent. V1, v2, v3 means like V is a span of v1, v2, v3, right? Three vectors. I must show at least three vectors in V. Okay. So two vectors I have already shown. But V3 could be linearly dependent. I mean, it is possible this could be linearly dependent on these two, right? I mean, there is no condition that V3 is not linearly dependent. See, for you, all of these U1, U2, U3 must be linearly independent because dimension of U is 3. But there is no comment about the dimension of V. We can anytime make the dimension of, for the statement 1, we can anytime make the dimension of V to be 2. Okay. Still, statement 1 is true. I mean, we can have this kind of setup where U is having dimension 3, right? And V is having dimension 2, and intersection is also having dimension 2. Okay. Which means this is redundant vector. Okay. We can anytime have this kind of setup, which means see here that here I've only made these examples, like the way I'm explaining is basically using this visualization. Okay. So I mean, I'm not copied this from anywhere. This seems to be only my way. Okay. I've not seen any other place where like these kind of things are explaining in this way. Okay. Anyway, so basically I'm saying that this is U, and V is this, where this D could be redundant, right? Yeah. So basically, the linear dependence of this v1, v2, v3 is not necessary. Okay. Because this could be the redundant vector. So that's why this is false. Okay. This is false. What about statement 2? Let's just see the statement 2 also. So what they're saying. Okay. So in statement 2, they are saying that let's just form u plus b such that it is basically u plus b, which means the every vector is getting summation with the every other vector. And this is R4. So basically they are saying u and v combinedly basically making R4. Then either this is linearly independent, or the v1, v2, v3 are linearly independent. So basically they are saying, let's suppose this is u, right? This is u. Here u1, u2, u3 are there. Okay. Now there is v. Okay. There is v, which is let's suppose uh like this. I mean, they combinedly they should be forming R4, right? Okay. So basically, let me tell you the with the diagram that it is possible that u1 u2 u3, okay, I mean, I'm just representing the basis vectors here. U1 could be just this, using the two vectors u, and I mean u could be just this and v could be just this, which means combinedly they can still form R4. Combinedly they can form R4, which is true, and there is nothing in the intersection, which is okay. Okay, combinedly they can form R4, but it is not necessary that this U3 is also independent. I mean, this U3 could be dependent on this A and B. Similarly, this V3 could be dependent on this C and D. Okay, getting my point? So basically, statement 2 is also false because it is not necessary that U3 is linearly dependent on this. I mean, it's independent on this, and similarly, V3 is also independent on this. Okay, you can make U plus B to be R4. Still, you can have V3 to be dependent on this, and U3 to be dependent on this, and V3 could be dependent on this, right? So basically, here I have written that you can think U plus B is a set of all possible vectors, U and B. Intuitively, one might say that the dimension of U plus B equal to dimension of U plus dimension of B, because it seems like you're taking all the vectors from U and all the vectors from V. But since the common vectors are counted twice, so we must subtract once. Okay, I mean, I'm just driving one formula, which is like popular formula. So, but do not worry about this formula. We will not use to solve this question. Actually, I was just writing the solution, so I thought I can also drive the formula. But actually, this formula is not important. Okay, for this question. Now you can solve the question without using the formula. You can say suppose that dimension of u is 2, dimension of v is 2. Then there are only two linearly independent vectors in the basis vector like this, right? So which means you can still make a u plus v to be R4, and then you can still work. Okay. So here both the statements are actually false. Okay. So D is the correct answer. Both the statements are false. Now let's solve this question. So this question was related to something called similar matrices. Okay. First, let me tell you what is a similar matrix. See, A and B are the similar matrix if there is a matrix P that exists such that P inverse AP equal to B, which means which means that this B and A are called similar matrices if there is some P which is something like this. Okay. If this P is called change of basis matrix, which is fine, but yeah, this similar matrices hold some property, which is basically they have the same determinant, same trace, same rank, same eigenvalues, and all. Okay. Now this question could be solved very easily if you know the similar matrices concept. So if you represent B, then you can represent B as you can multiply with the A inverse both sides. So it will be A inverse minus B A, right? Now you notice that B is similar to minus B. Okay, so the similar matrices has this notation. Okay, I mean this is called similar matrices. So B is similar to minus B, which means I can say the trace of B is same as trace of minus B, same as trace of minus B, which means the trace of B is same as minus of trace of B. From here you can say 2 into trace of B is actually 0, which means trace of B is 0, right? Okay, so trace of B is 0. And similarly, you can find out trace of A, which is also 0. How? From here, you can say that you can represent A also, A equal to minus or maybe B minus A into B inverse, right? So you can say that, okay, if there's a matrix B such that, or P such that that matrix and that inverse of that matrix, okay, I mean you can write B inverse here and B here, or which means like, I mean, it is okay, you're representing like this or you're representing like this. Okay, P A P inverse, I mean there should exist P such that here whatever is the matrix inverse should be here. Okay, here whatever is the matrix inverse should be here. So so B A and minus A is also similar matrix. So similarly, trace of A and trace of minus A will also be same, right? From here you can find out trace of L 0 and trace of B is also 0. Okay. Yeah. Now let's solve this question. So this question was based on just one easy property, and the property says that that I mean, we have seen this property in PCA. Can you just try to recall that property that we are trying to, make use of? Just think about it. And the property is basically we have seen that property is in PCA. So it says that if you want to find out the maximum value of AX, right, such that the length of vector X is basically 1. In that case, the maximum value turns out to be the lambda max, which means eigenvalue, which is the maximum eigenvalue, you can say. Okay. Now, if that is also, within the absolute value, which means if that is also within the mod, then it will be also within the mod. Okay. So this is a property which is very interesting property and very important property also. The same thing they're asking. They're saying that there's a polynomial which is defined like pt equal to 1 plus t, and they're asking p of a. P of a means 1 plus a, right? Or I plus a or something like this, right? So basically they're saying there is one matrix, okay, which is like I plus a, okay, into x. So if you want to find out the maximum value of this, okay, maximum value of I plus a into x, then you can say it will be same as saying that whatever is the maximum eigenvalue of I plus a. So if a has the eigenvalue lambda 1 to lambda n, then I plus a will be having the eigenvalues lambda 1, 1 plus lambda 1, 1 plus lambda 2, similarly 1 plus lambda n, right? This will be the eigenvalues of I plus a. Okay. Now, if they're putting that in the absolute form, so you can also put it in the absolute form. So you can say whatever the maximum of this, it will maximize this also, right? So that's why this is the correct answer. Okay. So B is the correct answer here, which is the maximum of this. Now let's solve this question. What they're saying that A is M cross N matrix. Okay. So A is M cross N matrix, which means M rows and N columns. Okay. So M rows, and let me write in this way. So there are like m rows, okay, m rows. Number of columns could be, let's suppose, any number of columns, okay, n columns. Now, whenever you write, by the way, ax equal to b, in that case, you will be writing your x like this, right? See, your x will be matching this dimension 3. Okay, I mean x, the dimension of x must be this 3, which means x must be basically within Rm. Okay, if these are the m rows. Okay, now they're saying that any solution x can be represented as a sum of the vector from null space and row space. See, the x basically which is in Rm, obviously it can be decomposed into two. One is that null space, okay, and orthogonal to null space is row space. So that's why A is true, right? So see, the answer is AD and A is true. Why? Because any vector can be decomposed into two things, null space and row space, if it is in Rm, okay. Now let's just see the option B. So basically A is true. The system Ax equal to B is solvable if and only if B is orthogonal to every vector in the null space. See, B must be in the column space, right? And orthogonal to null space means row space. So basically, they are saying indirectly, they are saying B is in the row space, B in row space. But that's wrong, right? I mean, B cannot be in the row space actually. B has to be in the column space if we want Ax equal to B to be solvable. So that's why this is wrong. What about this? If if A is 4 cross 3 matrix and solutions of Ax equal to B are not unique whenever they exist. Okay, which means they are free variables. Okay, so there are like 4 rows and 3 columns, right? There are 3 columns. Then they are saying there must be rank must be exactly equal to 2. No, the rank could be 1 also, right? I mean, there could be one free variable, there could be two free variables also. Okay, so and there could be three free variables, which means the A could be entirely 0. Okay, so rank may be 0 also. So need not to be exactly 2. So that's why this is wrong. Now what they are saying, if x1 and x2 are the solutions of Ax equal to B, then x1 minus x2 lies in the null space of A. This is true. Why? Because if x1 and x2 are the solutions of B, then in that case ax1 equal to ax2, x1 equal to B, and ax2 equal to B. And if you subtract it, then it will be x1 minus x2 equal to 0. So x1 minus x2 lies in the null space of A. So that's why this is true. Okay. So A and D are the correct answers here. Right? Now let's solve this question. In this question, they are saying that u and v are the uniformly chosen random variables from 1 to 3. And what are the conditions? Basically, they are asking what is the probability that this quadratic equation is having some real roots, right? Real roots. Which means if you are having ax square plus bx plus c equal to 0, this quadratic equation, then it will be having the real roots whenever b square minus 4ac is greater than 0, greater than or equal to 0. Which means here the b is basically the coefficient of x, right? So 2u square, which is 4u square minus 4 into a is basically 1 and c is b, right? So basically it is saying that 4 you can take common, u square minus b should be greater than or equal to 0. Indirectly they are saying that u square is greater than or equal to b, then it will be having the real roots. So what is the probability of u square is greater than or equal to b if u and v both are belonging to 1 to 3? So you can check all the possible combinations, right? I mean, if u is 1, and then what are the possible values of v? Okay, if u is 1, then I think possible values of v are 1 only. Okay, if u is 2, in that case it will be 4. So the possible values of v are 1 to 3. Okay, if u is 3, in that case the possible values of v are again 1 to 3, right? Because it will be 9, so it will be 1 to 3. So out of all possible 9 pairs of U and B, right? 6 and 1 7 pairs. Okay, so you can say 7 are favorable out of 9. So which means 7 by 9 is a probability that U square will be greater than or equal to B, which means the roots will be real. So 7 by 9 is the correct answer. Okay, 7 by 9 is the correct answer. Now let's solve this question. So in this question, they are saying that x1, x2, x3, x4 are the continuous random variable. So this condition actually they have explained that this means that x4 is the highest, x3 is the minimum, and x1, x2 basically could be in any order, something like this, right? Lie in the between in any order. Okay. So they are saying what is the probability that x4 is the highest, x3 is the second highest, and x1, x2 lie in any order. Basically, if you have 4 random variables, right, then there are like 4 factorial, which means 24 permutations possible. In how many permutations this is happening? That's what they're asking. See, in exactly one of the permutation, x4 will be the highest, then x3, then x1, then x2, right? I mean, like that, right? In another permutation, could be x4 could be the highest, then x3, then x2, then x1, right? So basically, in exactly 2 permutations out of this 24, okay, x4 will be the highest, then x3, then x2, x2, x1 could be in any order. In exactly 2 permutations out of 24. Okay. So these are the basically continuous random variable, and so do not worry about the equal to. I mean, the x4 being equal to x3 is actually the probability 0 in case of continuous. Okay, so don't worry about the equality. You can just forget about the equality in this case. Okay. So I mean, you can even put the equality, doesn't matter in case of continuous. So basically, in exactly 2 cases, right? There will be out of 24 cases, there will be like 24 different combinations. Out of 24, only 2 cases are there where this condition will be satisfied. Okay, so 1 by 12 is the probability. Okay. Now let's solve this question. This is easy question. Here they are just asking probability of x being k. So x they have defined the x denote the number of tails observed before the first head, which means k times tail and then head, right? So x denote the number of tails observed before the first head. So basically, if k is the number of tails, so x will be k. Okay. So actually, like I was not thinking to give these in the exam. I was just thinking that okay, I will just give this in the exam. But then I thought maybe I'm like some of the people might not be able to interpret, so that's why I've given. Otherwise, this mathematical interpretation was not necessary because it is making the question very easy. So the probability will be 1 by 2 k times, right? And then one more time 1 by 2 for the head. I mean, head and tail will have the same probability for the fair coin. Okay, for the fair coin, which means this probability 1 by 2 power k plus 1. Sorry, yeah, power k plus 1, right? Similarly, this probability will be 1 by 2 power k plus 1. Okay, by equal to k is also defined something like this. Okay, here I think this will be k plus 2. Okay, it will be k plus 2. So by denote the number of tails observed between the occurrence of first head and the second head. Yeah, so this is interesting. By is denoting the number of tails, right? So will it be the k plus 1 or will be k plus 2? See, x is clear, right? X for x, there is no problem. X is clear. But for y, just think about it. See, first head has already occurred, right? Okay. So, I mean, you do not need to basically, I mean, the first has already occurred. You do not need to count this probability. So, I think, yeah, B is correct. Basically, by memoryless, yeah, the process start after the first head. Okay. So that's why this is little interesting. Like you don't have to count this probability. Okay. So which means k times this and then one more time. Okay. So B is correct here because the first head has already occurred. So mathematically, I think this is not exactly true. I need to modify this question. So this is not exactly true. This should not be there. I mean, this should not be there. This is not the mathematical representation. I should just modify this question. Okay. I will just modify this. Let's see this question. In this question, the covariance matrix is given. Covariance matrix means like this is the variance between x1 and x1. I mean covariance between x1 and x1, which is the variance of x1. So basically, covariance matrix is something like this. Okay, x1 will be here, x1, then x2, then x3, and then here also you will be having x1 and x2, then x3. Okay, so this will be the variance between x1, 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 x2, x3, x1 like that, right? Now they are saying suppose the random variables x2 and this some random variable are independent, which means the covariance between these two are zero. So basically the covariance, let me just tell you by the way the formula of covariance. We have already covered these things in the class, but here I'm just telling you. If you have something like this, then it is basically covariance between x1 x3 plus covariance between x1 x4 plus covariance between x2 x3 plus covariance between x2 x4. Okay. So they are saying that covariance between x2 and this particular quantity is basically zero. Okay. So you can write this in this way. Basically, this will be covariance between x2 x1, x2 x3, and x2 minus x3, something like this, right? So this will be the thing. And since it is zero, okay, so you can put dash to be zero. Now you can take these values x2, x1. This is one. Okay. You can take these values from here. Okay, this is one, this is three, this is c. So from here you can easily find out the value of c. Okay. Now let's solve this question. So in this question, they have given two codes, code A and code B. Code A is basically very easy. This is just using the same n, okay, which is 5. In code B, this is little interesting. And here in the code B, actually, let me just tell you that if you are having n equal to 5 or something like this, right? I mean, if you are having this default parameter, then this is evaluated only once. Okay, only once. So you're not going to evaluate it again and again. Okay. So let's just solve for code A and code B. So basically in code A, they are saying that n is 5. So you are decrementing n and then printing it. So 4 will get printed. And then you are doing the same thing. Then 3 will get printed, then 2, then 1, then 0 will get printed, right? So 4, 3, 2, 1, 0, it will get printed. Okay. And then in code B, you are basically saying that n0 is 5. Okay. So don't worry about this n0. It is 5. So n0 minus equal to 1. So initially 4 will get printed. Again you are calling, and then since it is evaluating once, then 3 will get printed, 2 will get printed, 1 will get printed, and 4, 3, 2, 1, 0, right? I mean the output will be same. This is a easy question. So A is the correct answer here. Okay. Now let's see this question. This is again a Python programming related question. So here P and Q are x minus 1, y plus 2, something like this. And then we are modifying P and Q something like this. Okay. Then they are asking what will the function 3 1. So f 3 1 will basically call, if you notice, it will call f of p value will be basically 2 and then 4, right? F of 2 4. and xy will become 2 4. It will call f of 2 4, and then it will call f of, this value will get decremented by 1, this value will get incremented by 2, then 0, and then uh, so basically this is 3 1, and then 1 plus 2 is 3, right? So yeah, this is 3 incremented by 2, this is 5, and then 0 7, right? Okay. At 0 it is returning this by directly, which is 7. That's very easy. So like this you can see this. Okay. Now let's just move to the next question. So in this question they are saying that using this graph, which is a graph of g dash x, not gx. Okay. They're asking you that which of the following of these three statements are true. Okay. So first statement is saying that g has the local maximum at x equal to 0. See, if it is going from positive to negative, then you can say there's a local maximum minimum. Okay, positive means it was earlier increasing. Like, let me just find out the value of gx. So see, at 2 there is an inflation, or 2 there is a change, basically not inflection, there is a change, which means from positive to negative, which means before 2 it was increasing, and then it started decreasing. So at 2 there is a minima, right? At 2 there is a minima. At 5 you can say, at 5 it was negative to positive, which means g dash x negative means it was decreasing and then increasing. Sorry, it was a maxima. Okay. And at 5 there's a minima. Okay. At 2 there's a maximum, at 5 there's a minima. At 4 this is 0, g dash x is 0, so you do not know anything. Okay. At 4 you do not know anything, so you can say at 2 there's a maxima, at 5 there's a minima, so only 2 is true. Whether G2 is exactly equal to G5, you cannot infer. I mean, G dash 2 is exactly equal to G dash 5, but about G2 and G5, you do not know. Okay. G is the local maximum value at x equal to 0. You don't know. And x equal to 4, you don't know, right? I mean, 0, 4, you don't know. You only know this. Okay. So only 2 is true. Okay. Now let's see this question. This question was a bit interesting in its, on nature. So basically, this question is saying that how many support vectors will be there if you have c equal to 0. C equal to 0 is very interesting case, which means you don't have this at all, but you have this. Which means you're allowed to take any slack that you want. Okay. I mean, because the slack is not having any penalty. So you're allowed to take any slack you want. And you want to minimize this. See, the minimum value of this will be obviously 0. You can anytime put w to be 0. And and this epsilon I, you can take any high. Okay, any high. There is no restriction on this, because the penalty is actually, there is no penalty, you can say. So w will be, the final w will be 0, and if you see the margin, which is 2 upon w, it is actually infinity, which means you can say that that, see, geometrically there is no, I mean, w equal to 0 doesn't have any significance. So don't try to draw it geometrically, but still let me just tell you then what does this mean. That all of these will be in the penalty. I mean, all of this could be misclassified. Okay, will be in the penalty region, will be in the margin region, because margin itself is infinity. Okay. So since all of this is in the margin region, so you can say all of this will be the support vectors. So how many support vectors will be there? 3, 4, 5, 6, 7. Okay. So 7 is the correct answer here. See, don't try to draw the margin geometrically, or don't try to infer that what is this w equal to 0, because w equal to 0 has no meaningful separating hyperplane. Okay. This margin covers the entire space. Hence, this every training example here is a support vector. Okay. So this was very interesting question. So that's why I put it, and the answer is 7. Okay. So this was the complete discussion of AIMT2. I hope you really liked this discussion. Okay, just let me know in the comment section if there is any doubt or anything. So I know most of you people were waiting for this discussion, and finally this discussion has happened. So thank you everyone for your patience. Really liked the thing that you are not being too impatient, and thank you so much for watching the lecture. Thank you.